Hi, everybody.
Hello.
Hello.
Happy Valentine's Day to all my Propeller sweethearts. So you're looking at a picture from John Huffman. This is a project he made using a propeller, and it's a pollination system. He lives in the Central Valley, so this seems appropriate. Chip has also worked on a similar system. I don't know if he's here, but he can tell us about it. He seems not to be present.
It'd be
So
fun for everybody.
today, February 14th, if you want, you can go over to the forums if you want to run some of Chip's code that he'll be sharing today. I'll put a link in the chat, and you're viewing the forum thread.
And you have 99 messages.
What's that, Ada?
He has 99 messages or something like that.
Oh, I do. Yeah, I gotta go in here and clean this up. Not doing a very good job. Maybe you can answer them for me. I'll give you my login. So today, Chip's going to talk about the pieces of the self-hosting computer and what he's currently working on, which is the HDMI part. And before Chip starts, just want to be sure that you've all seen this. I see that Mike Harrison is here, and he has a few of these on the way to him, and so does Kenichi in Singapore. So Kenichi, expect a week or so due to customs. We had 100, we have 21 left in stock. And we're building some more, but it will take a few weeks. So get a look at the Flip Protoboard kit. Here's the link. Drop that in the chat.
Yeah, looking forward to these landing. Says Friday they will be here, so excited to play with them over the weekend and try it out.
All right. Good. Let us know what you think. It's not closed to further suggestions and revisions, but we think we got it pretty close.
Yeah, just
All right.
looking at the layout and the silk screen, I'm pretty excited about the way you did the silk screening both sides, so should work for the students.
Oh, good. Yeah, I wish I had one present so I could zoom in and look at the board, but I don't. All right, so before Chip starts in, questions, comments, anyone have any needs from anybody here in the group or from Parallax support-wise, or have anything to share today? I see one request that's a direct message to me saying, can we please have a reliable SD card driver? So I know that has to be on Chip's list at some point for self-hosting computer.
Yeah, it is.
Though, as usually said as an answer to this exact question, the FlexSpin FATFS thing that it has is actually very reliable. I've never had that one fail, unless it's like the actual card was like not in there properly. But that one's solid. No corruption, even if you just like yank the power. Perfect.
All right, maybe Chip, you'll start there when you get into this.
Yeah, I'll have to, I don't know. Yeah, so that is some C code that is compilable with FlexSpin that is kind of a standard file system, right?
Yeah, exactly. It's normal FATFS library. Standard FATFS library, and it can do a bunch of stuff. It can do long file names if you want. It can even do expat, I think.
Huh. Do you know how the power loss survivability is done in that system? Is there any trick to it, or?
You generally just have to flush the file when you're done with it to make sure that you can yank the power. So of course, if you yank it while you're writing, it's going to be a bit, it may not like that, but that really depends on what the SD card is doing inside of it.
Right.
But if you yank it while it's not doing anything, it works just fine. Or
Oh,
if you
okay,
reset
right.
it while you're not doing anything.
So that's like a mount, unmount kind of thing.
No, you don't even have to unmount it. You just have to make sure the file is flushed.
Right.
And I don't think
Okay.
even that. I think if your writes are aligned to block boundaries, it will actually not buffer anything because it's stupid to do that. Yeah, I remember now. So the way this works in the Mega Humor emulator is that so it has this 64K area that is used for saving stuff, and that's in the original hardware SRAM. And what it does is it waits until there hasn't been a write to that for like 5 seconds. And then it just writes that onto the SD card and flushes it. Now, in an earlier version of FlexSpin, the flush function was actually not implemented. It sort of went nowhere because there's a sort of layer in between where you can have multiple file systems and they all sort of appear as if they're mounted into a big file system. And that wasn't passing the flush through from that VFS layer into the FATFS, and it still worked. Because when you write something that's block aligned, it just writes it in one go. In fact, it will use multi-block write, so it's actually fast.
Interesting. Okay.
Chip, maybe before you
Yeah.
start, Shannon
Sure.
has a very brief effort to share update on a P2 project, so we'll get a look at that. If you're ready, Shannon.
Super brief, but I wanted to show I did make some progress up until last week when I let the smoke out of it. But I was talking about a console device that would be nice to have a keyboard hooked up to, or a mouse anyway. But and this port here is where I took interface boards on different projects, connect them on for doing testing, development, and easy to stop out the setup. But we're at that point now. I had this guy plugged in there last week, and whose fault is it that all these barrel connectors are the same size? So I plugged a 12 volt in instead of a 5 volt. I had the both ends up on the bench for different things, and I plugged the wrong one in and burnt out my USB connector, and I'm going to come back on since. Anyway, things are happening there.
So did the 12 volts harm the P2? Is that what you're saying? Or did it just hurt the interface board?
It just burnt out one of some little resistor right down there, and oh well, I had these USB connections going up to the touch interface on the screen,
Okay.
and the P2 is fine. This still works.
Okay. Good.
What's the use of the console, the application?
Yeah, that's the feasible there.
Hey, Shannon, your connection's kind of poor, so you're cutting in and out a lot, but I think we got most of that. But Ken asked you what the purpose of that thing is. I think. Oh.
Yeah, I've got a Johnny Mac board here with the breadboard on it, and I've been continually setting up stuff in the perf board and then pulling it out and setting up different stuff, and I don't know, it never gels. I never get one far enough along, and then I move on to something else, and it's hard to restart. So I was making this plug-in interface for being able to swap out different test devices, little projects I'm testing, or sensor interfaces or something. Had some, now I've forgotten names. I was hooking up the desktop plotting interface. Oh, it's been,
Is it called processing or something?
no. It's made just for, well, no, it'll go on all the Arduino stuff, but I can't remember the name. Somebody who's worked with P2s for a long time has written chapters in the books, had this interface view something. Anyway, it takes serial from the device and plots it on the screen.
Maker plot.
Maker plot. Thank you. I don't know why that escaped me, but I've been playing with that and expecting to make that reconfigurable, or reconfigure the maker plot interface depending on the board I plug in, depending on what I'm testing. It's as muddled as it sounds at the moment, but I hope to clarify things when it comes together and I begin to use it more and understand what are the key things that are more important for me or not.
All right. Well, thanks. Chip, before you start, Todd Crystal has a question. He says it can wait till the end, but sometimes we know there is no end.
Yeah,
So,
go ahead.
Okay, so get into the Wayback Machine to 2011, and I don't know if will focus, probably not. Anyway, that's Eddie over there. And so I'm doing an artificial intelligence project. I'm going to use Eddie for it. And so phase one is I want to drive it around, and I'm writing a PyTorch program that's going to do sort of a sensor fusion thing with the infrared and the ping sensors. And so finally last night I found some code that came on the board originally from December 19th, 2011. And it has no attributions to it. So, and normally the Parallax code has got, a header that said who wrote it. Do you remember, was that something that you wrote, or was that something that Microsoft Robotics Studio wrote?
is it spin code?
Yes.
Yeah, we would have written that. That's the original Eddie driver, and I think actually David Carrier wrote it. You're welcome to have at it. And I can put all the project files up on a Google Drive if you want to get them.
Oh, that would be wonderful. Yeah, and it's really the command structure. I've been kind of poking at it and getting some of them to work, but I thought a little more, to save me a little bit of time.
It was kind of a complicated thing because they had a laptop on it with a Kinect. Yeah. I don't know how far you're diving into that, or if you're repurposing this without a computer involved, but
actually I was one of the contestants.
Oh, so you have the original software and understand the original purpose of this.
Yeah, I don't have the robotics at home code, but yeah, they sent out 10 of them in the contest, and I got one of them, and so I have Eddie, but I think I'm gonna yeah.
I remember well. What a heavy, overloaded mess of software it was too.
It is yeah. It's a little bit of a mess, yeah.
Okay, so message me over your email address, and I will get the files up while we have our meeting.
Okay, I really appreciate it. Thanks a lot.
Yeah, and you're free to use all that source code.
Okay, very good. I will let you know how it turns out.
Great. Okay, Chip, you want to talk about HDMI?
Yeah, sure. So I've been working with the eventual goal of having the P2 kind of self-host. And so one of the things it needs is a video display. And I'm thinking that the HDMI interface is probably ideal, although it doesn't give us nearly the resolution we're capable of because we have to signal at 10 times the dot frequency. So I've gotten a quarter HD mode to work, which is like half of 1080p, which is 1920 by 1080. So this mode is 960 by 540, which is nice because it integrally matches up with the pixels on HD TVs. And I can signal it right over, 8 pins on the HDMI connector. So
I think that's
There's-
actually a different name, though. I think HD normally signifies 1280 by 720. So quarter of that would be
okay.
something different. Is it quarter full HD? Maybe it
Yeah,
has a
yeah,
different
quarter
stupid
full
name.
HD. Yeah, the 16:9 aspect ratio.
Oh no, I don't even have any monitors that are 16 by 9.
Gosh, I've been like breaking them and throwing them away.
Oh, I mean,
If
I
you were
have a
here,
lot of,
I could have gotten you one.
I mean, my monitor that I'm normally using, which is this piece of crap, something's broken with it. It keeps turning on and off on its own. This is like proper old. It says super slim on the front. You can't see it because the camera is too bad, but the camera is not as old as the monitor. This is what they
Right.
call super slim.
Yep.
That's what Video 7, which is a company that I don't think even exists anymore.
Yeah, I haven't heard of that.
Solid
Well,
fucking metal, though.
Today, everything, I mean, the cheapest way to buy a monitor is to just go purchase a TV. And they all have HDMI connectors on them. And the
Actually, I think I've seen some really cheap monitors on eBay, but they're all like 5.4.
yeah, okay. Well, if you get one with component input, then you can easily do like 1080p or full wide HD.
Yeah.
But anyway, I'm thinking about like I don't want to have the pain threshold too high for the users. We
Yeah,
can
I
have
think-
other modes that use full HD, but you're going to have to get a like a little.
Yeah, I mean, if it's gonna be a good thing that's like has a lot of features, it's probably gonna have a resolution setting. So it's like, but I think that's a good sort of default. Yeah,
Yeah, it's just a default.
I'm
Because
just weird. The
it's what's
widescreen monitors
standard
haven't
right
fallen into fantasy yet or something. That's why I don't have them.
Yeah, time has left all of the really good analog formats in the dust. I mean, we
Yeah,
can
that's why I
signal
have
those
them.
with just 3 pins. It's beautiful, but 8 pins for HDMI, we can only go 1/10 the rate. So anyway, so I've got this mode working, and then I had developed that stuff for the debug displays on the PC in our Peanut app, which also goes into Prop Tool. And that was like really difficult stuff to develop. It was really hard, but I translated that into P2 code, and also kind of like in the rediscovery of how the thing works. I couldn't remember why it did what it did, but I had to get back into it. And so I kind of optimized it a little bit, and then on the PC side, and then I was able to implement it using the Cordic on the P2. And anti-aliasing is really cool because what the idea is that instead of having a line with jagged pixel steps as it goes down, what you do is you blend against the background for those partial pixels. And it has a way of like almost hiding the resolution limitation. So let me put one of my cameras on here and I'll show you. Let's see. Here it is. See, is that going yet? Doesn't, oh, wait, hold on. Oh, I have to say start video too. Let's see, it's not letting me select my camera. Why would it do that? Oh, I know why, because I'm using it in the Visualizer app. Let me shut this thing down.
Hey, Chip, do you need one of these? It's like a data path capture card.
Do I
These
need
can-
one? Maybe.
With these, you can actually just have a DVI port on them. You can just plug stuff into that. It's either analog or TMDS digital. it will actually capture it pixel by pixel. So it's actually like
Yeah,
fucking raw.
that would be good for HDMI.
Now the question is, why is this not in the computer? The answer is because this doesn't have a real bracket on it. Normal card would be like this, and it's like this, which is kind of a problem.
So
And
what is,
I don't know where this came from. I bought this used. Ray on the forums actually helped me buy this from the US. And the other thing is that there's funny issues with the Linux drivers. Not like catastrophical, but it does work on Windows perfectly.
huh?
And
That
it does
seems
work
like
on
maybe
it does
very
work on Linux, but if the frame buffer is in a sort of certain size bracket, like some certain power of 2 bracket, it will just fail to create the frame buffer.
okay.
Bizarre.
Yeah.
We'll have to look into what the driver is. But if you have a Windows computer around that you can put this in, buy one of these. They're good. And you can sometimes get them cheap on eBay. These are called
Don't they have
Data
things like that would just take, that would have USB interfaces these days?
Yes, but they don't, but they're all like for idiots, also known as capital G gamers. And they put compression on the video because you can't actually full HD
so
video
they're
through a
kind of-
USB interface.
So
it
they're
would work for
converting
low res video, but they
JPEG.
don't cater to that. So they're all compressing the video, even if it's
Right.
low res.
Got it.
This, of course, has a direct viz, and so it plugs into the computer and can just send uncompressed video. And of course, this one has the advantage of also being able to do VGA with an adapter. And if you fiddle with the settings, you can even do component.
Okay.
I have a capture of that, doing component
Yeah,
capture.
eventually we
very
might
good.
need something like that.
It's just, you know, my forum handle. Just ask me if you want to know where to get one of these.
Yeah. Okay.
It's
I
like
think
ancient.
that's- Right. Okay, I have my camera working now. I'm going to just pick I see what I see on my little window among everyone else's is very pixelated. So I'm just going to, let's see, if I click on mine, can I make it bigger? How do I do this? Pin. Okay, there we go. If you pin my square, you can see this, looks like a capsule rotating. Anyway, this is just the line draw algorithm, but at 8x pixels, so that you can see what happens in anti-aliasing. And then here it is with some translucency, just throwing lines up on the screen.
I like that it has proper line caps.
Oh, you say it does have proper line caps?
Yes, it has line caps. These
Yes.
round things at the end of the line. Pretty good.
Yeah, having rounded end caps is important because when you connect, when you draw something from point to point to point to point, you want those junctions where the lines where those points where lines overlap, they need to have rounded endpoints so they don't, have
otherwise they
many
like drag
artifacts.
out.
Yeah. So for most, real thin lines, it's hardly noticeable, but for big lines, it makes a difference. Anyway, I don't think this camera is doing it justice, but what I see in front of me, like this right here, these lines are incredibly smooth. You cannot see any staircase stepping in them. And it's not that high a resolution.
I can see some staircases on the video, but it looks more like the shitty compression.
Yeah, I mean,
like the camera captures the line, but then the shitty compression applies chroma subsampling, and that creates a staircase.
Right.
Amazing.
No, I could see that. Yeah. Anyway, so I posted this up on the forum. Anyone can, it's just the same program that I'm running right now. If you plug in an HDMI monitor, you should be able to see this image. Now, Roblo noted that I had the H-Sync may be too short, because I found that in order to get to 60 Hertz at this rate over HDMI, I needed to cut down on the kind of extra timing that's in video signals. It's all kind of a carryover from the old analog formats where the TV needed time to retrace its E-beam to the left side of the screen or to go from the bottom back up to the top of the screen. But in digital formats, that's all, in theory, superfluous. So I was
For
able to
HDMI,
like,
it's actually not, because you can send data in that H-sync area.
okay, yeah. It would be good to know what the limitations are, because I just kind of pushed it to what works on my TV and what, makes a contiguous signal
What the
out of the
TV
streamer.
needs, I think that's just dependent on the TV, what it accepts. If you want to send a data packet, I think you need you need 32 cycles for the packet. You need to have at least 8 cycles of preamble, 2 cycles of guard band, or 6 cycles in total of guard band if you count the video guard band, and both guard bands for the data packet.
All right, hold on. I'm going to write that down. Ada, say that again. This is for like
I have
the
to-
porch in the back porch.
For the entire sync area, well, technically you want the data packet to not cross over them. You can do it, but it's just gonna make your brain hurt when actually building the packet, because
Yeah.
it has to know that. So you need, I think, 8 pixels of preamble for the data packet. These are just blanking normal. Then you
Okay.
need 2 pixels of guard band for the data packet. Then you need the actual data packet, which has 32 cycles.
Okay.
Then you need another guard band, which is another 2 pixels.
Okay.
Then you need another preamble for the video, which is another 8 pixels. Then you need the guard band for the video, which is another 2 pixels. That comes up to 54 total.
Okay. Yeah, I'm doing a lot less than that. I think I'm doing like 24 or something.
I think that's the minimum what you need if you want to send audio with the video.
Oh, okay. To be able to pack audio also. Got it. Okay. Well, that's good to know. I'll ask you more about that later, I think, because yeah, I would like to eventually be able to push.
Think you might be
audio
able
too.
to cut the preambles down a bit. I think they're not technically necessary, but I don't know.
All right.
This is not an actual HDMI resolution from the spec, right?
This is, let me unpin myself here so I can see everybody. No, this is kind of a mode, quarter HD, this was sometimes called, was on cell phones. It was common on cell phones like maybe 10 or 12 years ago. Now cell phones are like, maybe between 2 and 4K displays, maybe more.
Yeah, it's like
cases.
bizarre. I think my phone has like a 1440p display. It's very
Okay.
pointless because you can't see the pixels anyways. It's so tiny. But it has that.
Yeah, so this is a mode that is we can signal over HDMI at 320 megahertz. And because it is a quarter of 1080p on both X and Y, it's nice because the pixels mesh up with the TV you plug it into. So that there's a nice, 1 to 2 match, or 1 to 4 match. 1 to 2 by 2 or 1 to 4 by 4 if it's a 4K TV. So it's just as like a nice fit for TV, and we can signal it. So, and it's a sufficiently high resolution that you can do nice stuff with. It's not 1080p, which we can do, but we have to use an analog converter to get to HDMI. And so this is something that the chip can just do natively right off the pins. But I'll have to, make sure it's formulated so that I have the proper guard bands in place so that it should reasonably work on everyone's.
The funny thing about the guard band specifically is that if you just add the guard band to your otherwise plain DVI signaling, it will actually show up as a pink stripe at the side of your image, and it will be shifted 2 pixels over. In my experience, they only start properly accounting for the guard band if you also send the data packet. So if you have an actual HDMI signal with data packets, you have to send data packets probably every frame. You cannot stop, otherwise it will get confused.
That's been my experience as well. You have to send the data packet before a device will say, oh yeah, this is actually HDMI.
Ah, okay.
Well, you generally want the data packet always anyways, because you can stay what do you, well, if you're not doing audio, then you kind of don't have much to do, but there's like this info frame packet that you can send, which will put, which may put the display into YAF mode or something like that. Like if you're playing a video or something, you might want to do that or something.
Speaking of audio, I have a lot of questions. I want to know if anybody tested audio, but Chip, if I understand correctly, you're rendering this into external RAM and then streaming it back in on the fly. Is that right?
Yeah, so it's going into PS RAM because we have these P2 Edge modules that have 32 megabytes of RAM. It's arranged as like 16-bit data path by 64 megawords, but you have to read like double words or longs at a time. So it's 8 megalongs. So the image is being stored in there because to buffer one of these screens at 24 bits per pixel takes 2 megabytes or 1/16 of the memory. So yeah, I write it in there and then the video driver reads it back out and displays it over the HDMI port.
The next question I have is the buffering, do you buffer? And if not, is the latency to PS RAM low enough that that's not an issue?
Yeah, the PS RAM, so to serve the image ongoingly to output for HDMI, it takes about 40% of the overall PS RAM bandwidth. So there's plenty of time left over to write the data, to read, write the screen data. So we can't probably do like, detailed full screens at 60 hertz, but we could get an update every, 2 or 3 frames. Does that make sense?
Yeah, definitely. Yeah, thank you.
And I have some page flipping in that little example I posted. So it sets up two 2 megabyte buffers in the PS RAM, and it displays from one while it writes to the other, and then swaps, so that you get flicker-free video.
How many cogs does this use?
I'll show you the code. It's just so one cog does the HDMI, and then one cog is dealing with the PS RAM. And then my other cog is just, giving commands to the PS RAM driver to read and write, whereas the video driver that takes one cog is issuing read commands. And it does them so infrequently that it doesn't even bother to verify that it happened. It just gives the command and assumes that it happened because there is plenty of time and it's going to get around to that. The PS RAM driver will loop and discover that command in time anyway. So I don't even verify. I just say, I need this next, and it puts it into a line buffer, which I display. And then I actually have it kind of like swapping line buffers too as it goes, so that I'm loading into one while I'm displaying from another. So that's just one, horizontal line across the screen. So that's what, 960 pixels by 4. It's like 3K or so.
Yeah.
A little under 4K of hub RAM that it takes.
Very cool.
I'll share my screen and then I can show you the code. It's pretty simple. Let's see. Okay, share screen. Where did they go? Here we go. Advanced portion of screen. Okay, so here, I don't know if maybe this is going to look better than the camera did, but can you guys see those lines?
Yep.
Okay. The code, let's see, there are 3 parts to this. I'll show you the actual RAM driver. Let's see. it's this thing right here. No, not, yeah, this is the PS. No, actually, this is the thing that renders the HDMI. Okay, so it just reads it out of memory, but it's not that long. If I scroll through the whole thing, let me get it tucked in so it's all in the window here. Here's the main loop. No, excuse me. That's the setup. This is the field loop. So once the thing runs, it's just running this code right here. And then it calls these blank routines. One of them is a blank line. One is a blank line with vsync. And then here's the data. Then there's some uninitialized data. So there's all the data. Here's the subroutine and the main field loop. Here's the setup for it. And then the front is just a spin interface that allows you to come in and tell it where you want it to get your video data from and what pins the thing is connected to. This thing right here is like, if I compile it, wow, it's only 332 bytes. And then it has a bit of var space because it has those 2 line buffers that it swaps. And then the PS RAM driver that actually talks to the PS RAM is this. This is pretty small too. So this is the spin interface that helps you set it up, and an explanation of how the command works. It's like a 3-long structure, and every cog has its own command that it can set. And so this is the setup for the PS RAM driver, and here's the loop that looks for the command from whatever cog has issued a command. And then this right here is the part that executes the actual command. And then here's the part that does the work. This actually reads and writes a block, and it has some subroutines and data at the end. This thing is, so the PS RAM driver is like 724 bytes of code. So those 2 things are what are making it play. And then I have, you know, here's the actual application that, let me get it to fit. Hold on.
Is the reason for using PS RAM just so you could get to 24-bit color? I mean, would you have necessarily used it if you were just going to do like 8-bit color? Or would you have used hub RAM in that case?
Yeah, well, for lower bit depth pixels, yeah, you could just use hub RAM. That would work.
I know it would work, but also, what's the advantage of using hub RAM in that case? Is there any advantage, or?
Well, hub RAM, it's always there. There's just not, you know, there's only half a megabyte of it. And so if you were doing like maybe 4 bits per pixel, so 16 color display, that would work fine. But if you want to be able to, the nice thing about going to 24 bits per pixel is that you can do this alpha blending stuff. So what you can do is kind of like, in a lot of ways, hide the limitations of the resolution by smoothing things out. And I have fonts that are using, you know, anti-aliasing as well, that are kind of like fixed, but they look really good even at very low resolutions. So, but it's all kind of driven though by the fact that I can only get data out of the HDMI interface so quickly on the P2. So I'm kind of like, I have to make some compromise. You know, I'd love to do 1080p, but it's just too, I could do it in analog. Could I do though the whole 24-bit per pixel? Maybe not, because no, I couldn't. I could do 8-bit per pixel, maybe 16, which would be high color, which would be decent, but I couldn't do like full, you know, 24 bits. But when you get to 24 bits per pixel, it's nice because you can blend anything and make the display look really good in the end.
Right. I think if I'm understanding you correctly, you're talking about even, say, white text on a black background, which is basically monochrome, but with the 24-bit anti-aliasing looks noticeably better or far better.
Oh, you can make it look a lot better. I mean, you're still going to have the constraints of where a pixel can and can't be, right? But you can hide, but you can make things look like curves that are really still very blocky because of the grayscaling that you can do.
Or you can mostly do it with 16-bit if you want as well.
Yeah. Yeah, we could do that, and that would take half the data. You know, Ada, I was thinking so much that I wish I didn't do the 565. I should have just done 555 because we have 16-bit VG or 16-bit mode where you have 5 bits for red, 6
Yeah, I
bits.
know about the 565.
Yeah, so
It's
you
kind of-
you never have true grays. You go between like purple, green, purple, green, purple, green as your grays step up, and so it would have
It's
been
good
better.
for like photographs, but it's not so good for well, anything else really.
Yeah, photographs can maybe have an advantage because you don't notice that kind of stuff, but for graphics, it would have been so much cleaner if I just
Yeah,
left it at
555
5
with an,
bits.
and then just use the top as like alpha.
Yes. Yeah, that would have been way better, but I was thinking of just maximizing the data that we had, so I
In
figured.
fact, there's an even smarter format that I've seen only one place, which is the sort of ArtX custom GPU that's in a GameCube and a Wii by extension, which is it's 555 with a top bit. If the top bit gets set, the meaning of the rest of the word changes, and you've actually got 444 and then a 3-bit alpha.
Yeah.
So it can do alpha blending, but it can also do good quality opaque.
Yes.
Kind of very smart, but
Oh yeah, I
never
wish
seen that anywhere else.
if that had come up during development of the silicon, I would have done it that way, but I just didn't know, and no one thought to say anything about that. So
Yeah, I
it's
think I wasn't
565.
around at that point. I don't know.
Yeah,
if
yeah.
you've known about
Had you
that thing
been
at that
there,
point.
yeah, it would have been done better, but
I mean, 565 is serviceable for like, you know, color graphics, but yeah, for like white text, you might have a little bit of an issue. Or maybe not. You'd have to try how that actually looks.
yeah, we could try it out. But the trouble is because green, let's see, green has one more bit. Even if you lock them all to 5 bits each and you just keep the LSB of the green always 0, it still has this thing where it wants to go between like a little.
Yeah,
from
you get the
gray to-
in-between values because it expands it to 8-bit.
Yeah, when I expand it to 8-bit, I just take the
Yeah, but
6-bit word and then
just
add
ignore
the
it and
LSB.
just use the closest color, maybe with some dithering applied, and see how that looks.
Yeah, yeah, because that would be a lot more memory conservative. So we could do, you know, that at 1080p, but we'd have to do it over analog.
Yeah, I don't even notice it over analog. It's all wibbly-wobbly anyways.
Wait,
Well,
say
you
that
notice
again?
it if you have, you don't notice it over analog because the colors are all wibbly-wobbly anyways. Like, well, not if you have something like this funny data path. I don't even know if it's visible anymore, but this has like sliders where you can adjust the color levels individually, which I don't think I've ever seen anywhere else. And wow, you can make it so that the gray that you're seeing that's supposed to come out of the analog VGA port is actually gray on the capture, which is mind-blowing. It
Yeah.
really shouldn't be, but it can do that.
Well, yeah, all these gamma curves are being applied, and I think that gets things twisted up. But my experience with analog, it looks really good. You just have to have a separate converter box to make it go, which is like a $20 thing from Amazon, or maybe 17 bucks.
Not
Some
sure
are
how
cheaper.
do these really perform so well? Because
Yeah,
something that
well-
I noticed is that these have no settings at all that you can use to adjust the anything.
I have a couple, and one of them is definitely better than the other. And I think it's simply because they put more bypass capacitors into the
Have you
design.
tried putting like a checkerboard screen, like every other pixel black, white, black, white, black, white? Because normally that kills any improperly set up VGA converter, even like in an LCD monitor. You see these bands in there where it sort of shifts between the sampling phases because it's not properly set up. And interestingly, monitors that do have like an auto setup button, they will set up, they will always set up correctly if you auto set up while you're on that checkerboard screen, because they can synchronize to that very well.
Right.
Kind of interesting. I don't think I've ever seen this in like a manual or something like that. I think I just figured that out, that makes it work every time. You don't have to fiddle with sliders. So maybe just do that, display a checkerboard for like a few frames, and then the stupid converter box without controls, it sort of adjusts when it powers on, sees the checkerboard, it goes, that's a pixel there, and makes the sampling phase correct. And
Yeah. The converter I have that doesn't work so well, it tends to have a snowy background because I think they just didn't control the noise. They didn't bother to commit enough capacitors to quiet the supply down. So
I mean, that's just Chinese manufacturing,
Yes.
interesting money-saving choices.
yeah, yeah. Yep. Anyway, so that's the anti-alias stuff. Now, one other aspect of this, because there is this ability to blend, I also have it so that the pixels, you call out your X and Y with 8 subbits. So you can actually, between like pixel 0 and 1 or n to n plus 1, you can actually pick from among 256 discrete positions from one pixel to another on both X and Y, which is kind of a byproduct of alpha blending, is that you wind up getting a sort of superposition, not exactly resolution, but you can very finely control where your lines begin and end. And the alpha blending, by kind of blurring the edges of lines to different degrees, it can kind of like subposition the line at fractional, which are to your
Yeah, I know what you mean.
fractional pixel.
That's like the subpixel precision thing. That's
Yeah,
kind of
yeah.
important when you actually start moving the lines, because otherwise they just sort of jump between the pixels at the endpoints, and because the
yeah.
middle of the line is never exactly on a pixel unless it's exactly on a pixel. It usually never is, so it's just sort of the entire line sort of shifts about as the
Yeah, the
endpoints
whole
move.
thing, yeah, kind of like does this.
Interesting.
yeah,
I was posting
with
on the
that-
forum about the triangle stuff. So on the original PlayStation, what they had is they did not have subpixel precision. They just drew triangles from integer coordinates to integer coordinates. And now, if you've ever seen a PlayStation 1 turned on and running something that isn't just like flat sprites, you will have noticed that everything just sort of wobbles about, because
Oh yeah, yeah, it was really
while
rough.
the edges themselves stay in place, everything else is sort of basically it wobbles a lot because they didn't think to make the coordinates wide. And of course, then there's the other thing, because they just do an affine interpolation of the textures, and that sort of looks strange as this gets more perspective distorted.
Yeah, I'm thinking that because we can subposition pixels, or lines within pixels, or shapes for that matter, if we can make like a polygon drawer that does perspective and maintains a Z buffer in a kind of a map, just like the screen map in the PSRAM, but of just integers that say what is the distance. So anytime you get a closer distance, you overwrite the pixel
Yeah, I know how that
screen
works.
memory. But what we can do, because we were talking about that, you probably read we were talking on the forum about that. We can alpha blend we can't do whole polygons because you'd have to absolutely know the Z order of pixels in order to properly blend transparencies. But opacity doesn't care. If you have something superior, you draw over it, no problem. But we should be able to alpha blend the edges.
No, you shouldn't. It's not possible, because the edge isn't any different than the inside of the polygon, right? If the inside of the polygon has been drawn with some sort of semi-transparent texture, you say, oh, this has 80% coverage and 20% of what's below comes through with the alpha blend, right? Then if you draw that in the wrong order, if you have multiple of these, and if you draw them in the wrong order, it looks wrong. It's bad.
Oh, I see.
Now, if it's on the edge, you say, okay, this edge pixel is 80% covered. We're gonna let 20% through from below. It's the same thing. If you do it in the wrong order, it's gonna look weird. Now, in that case, it's of course localized to the edge. However, the parts where the edge intersects with something that's also semi-transparent or drawn in a different order, it's kind of
Yeah, you're right, Ada. I was thinking that it wouldn't matter because we do know that the polygon is opaque, so we should be able to confidently alpha blend the pixel. But you're right, because we're never going to have it in exactly the right order because it's going to alpha
Well,
blend in the wrong order.
You
it's
can
gonna
have
come
it
out.
in almost the right order. And then you can just get rid of any Z buffering if you want.
Oh,
You just need to turn your brain on, and instead of just processing geometry in the way that it comes in, you have to do it. You have to either pre-buffer it, so you have to either sort it into buckets, so that it comes up at the correct depth.
The trouble
or
is,
something smart like a BSP tree.
but like you said, there are some pathological cases where you cannot properly order. Here, let me show. You had posted this. Let me show this.
Yeah, exactly. You have to kind of. It's always a strange
Like-
trade-off.
This kind of case, how can you you can't properly Z order those things, right? Because
not if you do it for the entire shape, right? So of course the thing that you do with that is you'd either just not have this happen. Just don't make this. Just say it's evil, and if you build this Beelzebub, it's gonna come to your house and eat your knickknacks.
I can imagine that.
The other thing is if you do something like a BSP tree, like a proper full BSP tree.
What is
what it does-
BSP? Binary search pattern? What does that mean?
Binary space partitioning. So
Okay.
if you do a BSP, it's gonna split these up eventually. So there'll actually be multiple polygons, and they will have a order between them. And of course, I have to explain how BSP for ordering works, I think, if you've never heard about it. So
Steven just posted a link to it.
we have our space here, right? That's a sort of, it doesn't even have to be a 3D space. It could be a 2D space. In the original Doom, they use a 2D space. And but let's say 3D because it's what we're talking about. So you have your space and there's some stuff in it. So, and you want to be able to get this stuff in order, in a particular order, from closest to furthest or furthest to closest. So what you do is you do this offline because it takes forever. So you have to pre-calculate it. You pick a plane that splits the entire thing in half. You're gonna have two half spaces, right? With stuff in them. Everything that intersects this plane gets split into two things so that that there's nothing intersecting the plane. And then you take each of these half spaces and then recursively split those into two half spaces until all the half spaces that you have left at the end. Well, it's not even half spaces at a point. It's like sort of spaces. Just they only contain geometry that cannot occlude itself. So it's basically like a convex subsector. So what you then do with this structure that you have is you can tell if your camera position is on which side of a plane it is, right? So what you do if you want to go from back to front is you go to the topmost division and you go down the path that you're not on, the side of the plane that you're not on. And then you go to the plane that you're not on, the plane that you're not on, the plane that you're not on, until you're at the end of the tree, right? And then you've reached the furthest thing. Then you draw that, then you go up one level, and then you go to the one that you're on, the side that you're on of the plane. Then you draw that, then you go up the level again, then you go up the level again, and down again. And you draw the thing that's on your side. But no, you go to the division that's on your side, but then in there you go to the one that you're not on. It's a recursive algorithm. You go to the side that you're not on first, and then you go for that, you go to the side that you're not on, and you sort of go to all the front sides at the end. Does that make sense?
Sort of. I'll read. I'm going to save this link Stephen posted. I'll study this. So what do you think? So, okay, we cannot really, unless if we do something like BSP, then we can like have smooth edges of polygons.
Exactly. Then you can, yeah, basically you can get them all in order. And of course, if you have something like that, you can then use another sorting technique to sort of intersort objects between each other.
Okay.
because you know the BSP tree only describes one object that cannot change.
Right. Okay. So the obvious thing to do is like the PS1, just use whole pixels and render triangles on like full pixel boundaries and not try to do anything fancy, right?
It's not that much harder to do it with, actually, I did prototype this the other day just because I was thinking about it. Let's see if I can share this. I just figured out some algorithm in processing. Let's see, do I have share screen? Will it explode my computer? Oh, there we go. So that's something I prototyped the other day just because I was bored.
Oh, nice. So these are pixels.
It's sort of the big things. It's basically, yeah, the big squares are pixels basically. But it draws the line on over top where the actual shape sort of supposed to be, right?
Right.
You can see that.
Yep.
And so there's a few interesting things here. You can see that this can draw sort of any convex shape. It doesn't have to be triangles. And really, there isn't that much more to it to do the any shapes. The actually more complex stuff is deciding which pixels do we actually need to draw, because there's a very particular rule to that, which is whenever the line sort of makes it so that the center of the pixel, this little dot there, is on the inside, then it gets drawn. If it's not on the inside of the line, it does not get drawn. This sounds obvious, but it's kind of not quite
Well, yeah,
obvious.
because this is like a two-dimensional problem that you kind of have to reduce to a one-dimensional matter when you render the line, right?
Yeah, exactly. And now you see the blue lines are sort of where the actual line is, because you have to kind of do this in 2 dimensions. You're stepping through the scan lines, right?
Right.
And then for each scan line, you have to determine where's the left edge, where's the right edge at. And then there's another problem, which is when there's 2 polygons that are supposed to be next to each other, right? They share an edge. But say that edge falls on like an integer coordinate, so sort of goes exactly through a pixel. This should not be drawn twice, right? For many reasons.
You want to draw it once. And the beauty of this is that this works really nicely with the PSRAM because you get the advantage of being able to send,
you
send
can
a
burst
whole
right
stream
through
of
the entire
pixels at
line.
once, which is 10, 20 times more efficient than doing 1 pixel at a time.
Yeah, 1 pixel slow. But anyways, the problem when there's multiple polygons that share an edge and that edge falls on an integer is that it will draw twice if you're not super careful. So the general rule that you want, that's just the one that everyone seems to use, is if it's exactly on the left edge, then you draw it. If it's exactly on the right edge, then you don't draw it. The big gray shape.
So it's like a rounding problem.
Basically that, but also if you have a flat top that's on an integer, then you're gonna draw that. But if you've got a flat bottom that's on an integer coordinate, you don't draw that. That's evil. And that sort of makes it so that you can slot these together and they never draw a pixel twice, which if you're just doing opaque geometry, it's like, oh, okay, fine. But if you're doing something with blending, then that causes you an issue, because then that pixel gets blended twice from the same mesh, which is undesirable.
Interesting. So this is an algorithm that you have worked out that you're graphing the operation of, right?
Yeah, basically I've just can I share what the actual thing looks like?
Yeah.
Oh god, it's gonna the question is towards the computer. The computer may not want me to do it. It has a mind of its own. Also my ear hurts because the headphone is on it. So this is a cursed processing sketch. If you've never seen processing, it's like the thing that Arduino ripped off. But instead of controlling microcontrollers, it can draw things to the screen.
Okay.
But it's the same bizarre thing, basically, where you've got a program and you can click quick play. It's very useful for sort of figuring this sort of thing out.
Yeah.
For rapid prototyping display of your thinking.
Yeah, exactly. And the thing here is that I'm drawing very big pixels on a grid, but I can also draw the actual anti-aliased line over top. So it's
Yes.
very useful for seeing if it's actually working correctly. So the way that it works is we have this vertex array that we can put in, and we put a color in. And there's additive blending, so we can see if it's drawing twice, which it currently isn't. So so what it first does here is it finds the top vertex, so the one with the highest y coordinate. It does, I think, when there's a flat top, I think it does something very specific here. I have to remember. I think it has to be the rightmost of the flat top that it finds here, for reasons that are relevant to the rest of the algorithm. And what it does then is it tries to load a vertex, another one for the left side, and then tries to load another one for the right side. And so what happens is it always has to load a new vertex when it reaches one of the vertex, either on the left or on the right side. It has to load a new one and recalculate the slope on that side. And there's a slight problem when the vertex is not on an integer coordinate. You sort of have to do a bit of a partial step. I think this doesn't even do it optimally, where it skips the remainder until, so from the integer where we draw to the position of where the vertex is, we actually don't care about that last step at all. We only care about the step from the vertex to the next integer. I think I'm still doing the other one here somewhere, because just for consistency's sake. But we actually, of course, reset where the edge is to where the vertex is, just to not lose precision. So that last step actually doesn't matter. And then the main thing is just here that it iterates scan lines until the next vertex is going to be, which is trap bottom here. And then just draws them. And there's a very particular way that it has to round the x positions of the edges to get that effect where it doesn't draw the right edge if it's exactly on the thing. Exactly. So it has to get the ceiling of the left x, and then for the length that it's going to draw, it wants the ceiling of the right x minus the ceiling of the left x. Now, ceiling is a weird function, because what you'd have to do, now this is floats, but if you do it in fixed point, what you'd do is you'd have to add this largest number that's smaller than 1, so f something, into the coordinate, and then mask out all the fractional bits.
Right.
Or just shift them out, more likely. And that's what you'd actually need to set the coordinates. This may actually be faster if you invert the fill rule, maybe. I'm not entirely sure. Would have to think about that. Like if you say we want to draw the right edge when it's exactly, but not the left edge, which is functionally equivalent, right? In such a case, you'd...
Ada, how did you come up with the idea that you were gonna, like, as you add sections to the polygon, you have different colors? I mean, I guess that makes sense, you know.
you mean like the colors in the picture? It's actually multiple different polygons. If I go back to the
Oh,
other
so
window.
was the point that those were different colors, or that they were the body parts of different polygons?
The point is that they're different colors because they're different polygons that just happen to share edges with each other.
Okay, all right.
And,
wow, yeah, this stuff
the
is
thing
really
there was
hard.
to make the thing there is that I wanted to figure out is do they actually sort of share the edge correctly, so there's no gaps between them, but there's also no double drawn pixels.
Right. Yeah, that's very cool.
I'm always fascinated by how the information content in a presentation, in your rendering of the animated multiple polygons. You're showing us, how many different things are you showing us there? You're showing the pixel when it's being colored. You're showing the line across the dots that are telling us when it reaches over halfway through the pixel that you're going to color it. How many different things are you showing us here? You're showing us that the edges are being filled, when to color the edge pixels. Top and right don't get colored. I'm sorry, bottom and right don't get colored. Top and left do. What else are you showing?
Really just that. It does have these numbers here that tell you which vertex is which in the
Okay.
array that I'm passing in. But that's just for debugging, really. It's all just for debugging, but
Right.
it's not really
Helps you keep
relevant
it
which
sort of-
vertex is which. And it's
Right.
even overlapping when the vertices are shared. You can see this is 4 and 3 at one time, sort of overlapping.
What's-
Stuff like this looks simple and blocky, but this for me is so hard to reason out how to do something like this.
Not the presentation, but the actual algorithm itself.
Yeah, this is like
Yeah.
not trivial at all.
But
it is
Ada,
when you
this is
break it
fun
down.
to see. I just want to say this is really fun to see because I'm a deeply visual person when I'm trying to work things out. And
Yeah,
when
that's
when you're showing me this, it's just wonderfully easy to see what you're intending with the algorithm. Thank you. That's very
Yes,
cool.
and I think I actually really like processing as a tool. I think it would be better if they made it not use Java as a language, because Java is kind of a bit verbose. I
Right.
think if they made it use like a Ruby or something, it would be better. But I mean, there's a drop down that lets me. I think you can make it do Python, but I'm not a big Python person either.
I don't think you
so-
find much difference switching between the two.
No, but I like how terse Ruby specifically is. You can it's descended from Perl, and if you've ever seen Perl, you know what's up.
I spent years in it. Yep.
You can just write something, and no one else will understand it, but but you can write it very quickly.
I'm with you.
And yeah, this is just a little demo I made the other day, just because I was thinking about it.
As you're trying to reason it out to yourself, you do the demo to prove.
What
verify,
I need to do
pardon
next
the
is
term, but to
actually
verify the edge cases, the algorithm.
make like a version that runs it. That's actually fixed point and properly optimized, and also does the interpolation of values, because this right now is just filling it in with flat colors. But the real spicy part is actually mapping some value across it, be that like a color, so you can do Gouraud shading, or a texture coordinate.
And so
Right.
you'd fill in the edges differently based on percentage of occupation.
Well, that you could also do, but that's actually I'm not sure how you do that.
Well,
That's
see,
kind of-
the idea is that I think as you render this line, so you can see the blue lines as they go across.
Yes.
You have like X, like fractional precision.
Yeah, a fractional precision on
Scatters.
X. You could make it anti-alias in the X direction very easily, but but in the Y direction it's kind of complicated.
Well, you can use as you step from left to right, you can have like fractional delta values that can modulate the color or the texture pattern lookup address or whatever. So you could give this thing a gradient, or
Yeah, that's what I was talking about before. That if you wanted a gradient, you'd need to interpolate it between those points, right? Each
Right.
point
which is
has a
just an
color.
add. Every pixel, it's just an add.
It's technically an add per pixel, but you have to.
Well, two adds it for an X and a Y.
That's kind of a bit of a. It's kind of almost spicy. For one, now if you're doing a triangle, it's a bit easier because you can because everything has to be an affine transform. So the sort of X and Y increments.
What does
so the
affine
increment
mean?
Affine means that you can basically you can describe the transformation of the value as a 2x2 matrix, roughly speaking.
Okay.
What it basically means is that the increment per X and the increment per Y is constant over the entire surface, which it may not be if you're doing like a bigger one like this. So what you actually need to do in such a case is put some divides in, or because it's clipped to the screen before you're doing all of this. Well, if you know it's clipped to the screen before doing all of this, you can do a lookup table of reciprocals, because it's never going to be wider than your screen or taller than your screen, any value that you need to divide. So you can actually just use a lookup table for that if it's faster. But basically, you need to calculate the value that you're gonna add, and you're gonna calculate it once per edge and once per scan line if you're doing that. And that's kind of it's easier to do it with a triangle because it cannot possibly do something more complex. It cannot possibly change other than rounding error. So you can use the same increment values across the entire surface of the triangle. But it's kind of, if you're using that for texture mapping, both are wrong because you need to take the perspective into account.
Right.
But if you're doing it across an entire quadrilateral with with bilinear interpolation, like I talked about, where you do divide on every scan line, then it's less incorrect. It looks less weird because it doesn't have this weird line down it. Now the thing with texture coordinates, there's also something weird. There is it's kind of these two values that are packed into one value, which is your address, right? So you have the top of your address, which just tells it where the memory it is. Then you've got the Y, and then you've got the X, right? Sort of bit packed in there. If the texture is power of 2 size, that is.
I see that, like for the green triangle, you had vertices, you had points 0, 1, and 2, right? And then that formed a triangle. And then for the red one, you actually had 4 points, right? 0, 1, 2.
This has 5 points. 0, 1, 2,
Yeah,
3,
0 through
4.
4. Yeah, 5 points. And then the idea is that when you run out of points, then you connect back to the first.
Basically, no, you don't connect back to the first, because the first, in the order that we talk about, is the top one. We actually start by finding the top one, and then we sort of go around, and eventually it meets back up.
But you have to, when you're defining what are these called, vertices, these points?
Yeah, these are vertices.
Okay, so you have number 0, number 1, 2 at the corner, at the point, then you have...
They do have to be in clockwise order.
What's that?
They do have to be in clockwise order.
Oh, in clockwise order, I got it. So then when you run out, then you know to connect back to the first.
No, you don't connect back to the first, you connect to the other side. Because we're running we're going, the right edge goes clockwise, the left edge goes anti-clockwise. And they meet up at the bottom. You're sort of simultaneously iterating through the vertices. I'm
not understanding. So you've defined these as clockwise, because you can go 0, 1, 2, 3, 4, right?
Exactly. So the algorithm starts by finding the one that has the lowest Y coordinate. And then it goes and looks at the one that's one less with a wraparound if need be. And that's sort of the next vertex that it needs to go to on the left side, which will be lower. And it goes one up with wraparound if need be, to find the next vertex on the right side that it needs to go to.
Yeah, I can see how that you do that after when you want to render it, but by definition, it seems like you have some number of vertices, and then the supposition is that at the last vertice you connect to,
that's of
the
course.
Shape. You connect back to
in terms of the shape, it connects back to the first one. Yeah.
Okay.
In a sort of logical sense of what the shape is supposed to be. Yeah,
and then
the last one, the vertex connects to the last.
But do you get to reuse that data when you say you define the red one, now you're defining the blue one, you have some vertices in common. Do you have to call those out again?
In this particular case, I can just reuse the vertex object that I have a little object that has X and Y in it. And I can just reuse that same object, of course, because it's really just an X and a Y coordinate in this case. Now, if you're doing like a 3D mesh, you have to do like transformations on these, right?
Right.
And so what you would do is you define all your vertices in the front. You can transform them all, and you can do that in parallel because they're all independent of each other. And then you define, okay, there's a polygon between vertex 5, 20, and 13 in this order. And those are then the 0, 1, and 2 for that triangle. And then you build the triangle of those vertices that you've already processed. And you need to process them to sort of project them onto the screen and give them any light values that they might have, like calculate the angle of incidence.
Right.
That sort of thing. And if you're There's a problem, which is if the vertex ends up transforming off of the screen. So the problem there is that clipping of vertices, so finding sort of the vertex that has to go back on the screen, so that the entire shape is on the screen, actually has to happen in 3D space before the projection.
Right.
So you have to store the 3D position as well. You can't just store the final position, because the final position doesn't even make sense for one that's not on the screen. Because if your vertex is sort of left of your camera, right, it's going to have z equals 0. So if you divide by 0, it sort of explodes out into infinity.
Right.
And what that means is that what that means is that you have to, at that point where you would divide it, check if it's outside your clip planes, and then just store that it's outside the clip planes instead of the divided coordinate. And when you're building a primitive out of that vertex, you're going to realize, oops, this one's outside the clip area. We have to add new vertices in. Now, these new vertices, you might have to do an additional divide for these, but they're actually easy because they're always on the edge of the view frustum, right? So you don't actually, only have to do one divide instead of two. Or 3 divides if you're doing Z buffering, because there's a bit of a funny with coordinates.
In graphics cards, everything is triangles, right? So
exactly, they do triangles.
Yeah, because triangles.
Because it's easier to do the setup with, if you have hardware that does the setup for the triangle, it's easier to do it with a triangle because you have a fixed number of registers that have to sort of interact with each other. If you do more than a triangle, it kind of explodes in complexity if you want to do it in one cycle.
Right. Well, the nice thing about a triangle for 3D purposes is that it is always a planar thing. It cannot be non-planar. Any 3 points.
Exactly. If you're going to do some sort of skinning, you're going to use triangles as well.
Yeah. So, and then you have something that's definitely affine, right? Now you can linearly step across the surface.
Exactly. Now there's a problem with that, which is that you actually don't want to evaluate values linearly across the surface. You actually want there to be a perspective effect there, because I think that's a nice graphic for this. I can see if I can find an it should come up very easily. Thank you, Wikipedia. You have saved my life. No, if only we would load. Oh no, it was loading the Google image results sidebar. It was not loading Wikipedia. Now I'm on about blank. Woe is me. Maybe I'm just running out of RAM.
That's okay. None of us ever face this.
I have. Oh, there we go. That's the right. That's the good. That's the good shit. Give me this SVG and post it into the chat. Or just copy it into like a new window. Don't have you see my evil tabs.
Got it.
Interestingly, I'm probably more paranoid about other people seeing what I do on my computer, despite not doing anything weird, right? Like, I only have vague details, but there was this incident where a guy like shared a screenshot from his computer, and he had like some really weird pornography open in another tab, and you could like read the full title.
Yeah, there have been politicians in the US who had like done screenshots or Zoom meetings, and you could see things on tabs like that.
Yeah, that sort of thing. I think I'm more paranoid than those people are about that. Even though that's a bit TMI, but basically I don't watch for any sort of thing like that. I'm too something. Not interested in that sort of thing. But yeah, this graphic here.
Wow.
Look, so this is affine mapping on a triangle, the left one, right? This looks weird.
Well, if you kind of relax your brain, you can see that it could be a 2 planes meeting in space.
Exactly, that's what it looks like, but it's supposed to be right? On the other end, you've got the correct perspective, right? That's what it's supposed to look like.
And then quad only does it on the x-axis.
It does it on, you can see that the sort of x-axis is correct, but the y-axis isn't.
Right.
Because that's the one that gets the perspective stretch in this case.
Gotcha.
So what you get is that it looks almost correct,
Mhm.
but you don't have to do a divide on each pixel.
Yeah,
to
There's
get
something
the
that just
perspective
bothers
value.
the mind when you're staring at it.
So basically, there's a sort of, you have to do a divide on each scan line to do the quad, but it's a divide by the width of the thing. So you can kind of, well, if you want it with sub-pixel precision, you kind of have to have a real divide, I think. But do you need the sub-pixel precision when you're doing this? Because what you could smartly do is switch between these two, depending on the angle of the thing, right? So if you're looking at something straight on, or if it's like far away and small, you can use the fast method. And if it's at an angle and very close to you where you'd notice that it's weird, you could draw it with the perspective, and you kind of have to make sure that it's at just the right point that you don't see it pop from one to the other. I think there's some stuff that did this, which is kind of.
That's interesting. Now, there's something I could imagine that would be like the triangle with perspective would be fully, well, that would be a 3D, like not a plane, but two planes meeting.
Yeah, that's what it kind of looks like from the just the thing, what it appears to be. What happens here is that each triangle sort of interpolates between each vertices linearly, but because there's two triangles intersecting, not intersecting, being adjacent, and they have these three vertices, you can see that it's not like there's no discontinuity in the actual diagonal line that goes across there. It just can't sort of do that, keep it consistent across the entire quadrilateral. It's not actually more or less correct than the quad interpolation, but because we use square textures, like this checkerboard thing, it looks more weird.
All the
Whereas with the
outline
quad,
of all those are exactly the same, right?
yeah, basically with the triangle it's affine, so all the squares of the texture here are exactly the same shape. But with the quad, they actually do stretch a little bit.
You know, with sufficient resolution, you don't have to worry about sub-pixel smoothing because who's going to notice it? You know,
it's not moving on the subpixels. It's that the texture doesn't snap from one pixel to the next.
Yeah.
Sort of you need to maintain that the precision of the coordinates for each pixel. It's the same thing as with the lines, right?
Right.
It's just that instead of drawing an individual line, you're sort of drawing a line through the texture, if you will. Yeah, that's a good analogy. You're drawing a line through the texture.
So Ada, what you're speaking to by snapping is you're in successive frames as things move. That's
it sort of
the
moves
action
from
you're
one
talking
step
about.
to another one. It's not smooth then, right? Like if you see this zooming in towards you, the width only changes from one pixel to another because there's only that many pixels. But the actual positions that are sampled within the shape, they sort of do scale outwards and are smooth.
Okay. Thank you.
Kind of a.
So do you know in like the 3D graphics world, like the graphics card use they define all these triangles, right? And they must have a way to, so that every time they add a vertex, they're creating an additional triangle somehow.
The way they do it is there's actually many ways. So what you're describing as is what's called a triangle strip. But that's not actually a general use case. So if you imagine like a cube, right? Or maybe an object more complex than a cube, you can't actually describe that by like continuously drawing out triangles from the next one as a sort of connected strip. You actually would have to use multiple of those. So what the GPUs generally can do, they can do triangles, just individual triangles with vertices, with that same idea that you define all the vertices up front and then select which vertices you're going to use, because each vertex, if you have like a continuous shape, is going to use at least thrice, I think. You have to have at least 3 triangles that use a vertex. Otherwise, it's going to have being like an open end where the mesh isn't enclosed, which, you sometimes do that, but for properly enclosed mesh, you don't. There's always going to be 3 things using a vertex, so it makes sense to have the vertex only defined once. And then you have the triangle strips, which is basically we define one triangle, but then we create another triangle with just one other vertex and reusing 2 from the previous one.
Right.
And
there's got to be some economy
and
going.
that sort of, with that, you can sort of even draw an entire strip of quadliterals, even, because if it's quadliteral kind of positioned, the triangles sort of alternate. It's kind of bizarre. I think vertex 2 of the previous triangle becomes vertex 1, vertex vertex 2 becomes vertex 0, vertex 1 becomes vertex 8. It kind of complicates how that works.
Well, the strip could make a complex surface, but you just have to do it in a way where it's like
kind of bizarre.
A line. It's like a line of vertices that are making what winds up being like a 2D complex surface, right?
Exactly. And as I said, it's not that much of a thing, because we already process each vertex only once. So it's not that much of a difference between just creating a new triangle every time and just creating or doing a triangle strip or a fan. It can also do a fan, which is where it keeps the first vertex that you give it for all triangles, and then sort of uses the past only one vertex from the previous triangle. So it can kind of draw if you want to draw like a circle, you could give the center, and then you could do all the points around there, and then it would draw a circle. Or a circle, scare quotes,
right.
circle. But the thing is, the only thing that really saves is that if you're doing that indexed vertex thing where each vertex is predefined and you're just giving the index, the only thing it saves you is the memory for those indices. Indices, and that's already very small, because that's like 16 bits or something, versus needing at least 64 bits or something for a vertex that doesn't even have many attributes. If you have a lot of attributes, that's a lot of bits on the vertex. I don't even know how many attributes they have these days, but even a relatively basic thing would have, of course, the position with at least 16 bits per thing, more likely 32 these days, but I think 16 is actually okay. And if 16-bit integers, and that would actually, on the P2, that's actually very fast to multiply with a 16-bit integer, right?
Right.
You can gain a lot of, because 16-bit isn't really enough precision for everything, but if you scale it around, right, you may have a small object that has a lot of details in it, but you may have something large, like a building, but the walls of the building don't need sub-millimeter precision, right? For where they're at. So you can sort of scale those 16 bits to the object. And if you do it by powers of 2, you don't even have to do that many multipliers on the transform. You can just shift it around to the exact size that ends up being relevant.
I was reading also someone had posited of doing a microsphere rendering where you have a database of spheres that are smaller than pixels. But I could imagine also, because it's not hard to draw in nice detail like a circle. A circle made out of a bunch of triangles is always going to have a panel.
Yeah, it's always a bit iffy.
Yeah, but you could actually just have some kind of, it would maybe be good for data visualization, not a video game, but some
sort of, if you just want to draw circles, it's a lot easier to just draw a circle instead of drawing a bunch of triangles that approximate a circle.
Well, yeah, I mean,
which incidentally is what ends up being done on these GPUs these days. They're kind of more likely to draw a bunch of triangles. Well, now with pixel shaders, you can actually draw a square that's the size of the circle, and then use the fragment shader to discard all the pixels that aren't inside the circle.
Yeah.
Which is kind of they talk about squaring the circle, but that's circling the square.
Well, think about to render spheres, like imagine rather than, you can draw a sphere, it seems to me. Let's say you have a bunch of spheres in 3D space, right? Each sphere has a size and a color and a location. You could Z order that properly and draw and render those things pretty quickly, and also very
Actually,
easily.
spheres, no. Spheres are evil because imagine if they intersect.
Yeah, well, the Z buffer takes care of that.
Yeah, okay, if you're doing the Z buffer, then yeah, but then you don't need to sort them.
Right, you don't need to, yeah, I think that's it. You don't need to sort them. So you can only draw like things made out of roundish objects, but like you could do snowmen with eyes, and
Yeah,
and
there's some old stuff that worked like that, like where they just had spheres because there's some old like ray tracing demos because it's easier to do ray tracing with a sphere for some reason. And they always had loads of things made out of circles.
Yeah.
But they took like hours to render a frame or something like that.
Well, what you're doing to render a sphere, what you're really doing is you're just rendering a circle, right?
Well, in that case, you're tracing the ray and then sort of figure out where it reflects off the circle. But in that case, yeah, if you're just rendering forward, then you're just rendering a circle.
Well, I'm thinking. No, maybe
interestingly, something interesting about spheres is if you think about the reflections on a sphere, right? Like if a sphere was to reflect something, there's something interesting about that, which is if you take any other object that's not a sphere, take the sort of normal vector at each vertex, and then use that as a coordinate into a texture where you can see a sphere that's reflecting something, and sort of map that as a texture over the other object. It looks like that object is reflecting what's reflected in the sphere that's in the texture. This sounds bizarre, but it's called environment mapping.
Well, to render a sphere, you'd have to, as you trace across the surface to make a circle, really, you just have to have some awareness of what your Z is, and you know what you need for reflecting light sources.
I'm not Roger in that.
Hey, Ken. There we go.
I'm here, just muting.
Thank
Okay.
you.
So about a sphere,
That guy calling in from his like CB.
Yeah.
A sphere would be kind of it'd be incidental to shade it, because if you know where your light sources are.
Yeah, I mean, that's why I was saying the normal vectors on the sphere, they're sort of very nicely positioned. They sort of correspond to the position to the XY position inside the circle that you've got.
I mean, to make like a chemical simulator program, like a molecular simulator.
Yeah, you need to render a lot of spheres.
Yeah, it's just spheres. It's all you do is spheres.
Yeah, lots of spheres, and not sure how the Z actually goes across the sphere. How that interacts when you do perspective on the sphere. Now, if you're doing if you're just using the sphere as a data point, it doesn't matter. There's just something.
I think there's some simplicities there that kind of get around. Well, because a sphere is a sphere, you don't have to do such complex transformation of these vertice nets, right? It's just.
Well, you have to transform the one vertex at the center, and you have to transform the width and of the sort of radius of the sphere.
Right. Yeah, those two things. It's right. Where is the center, and then what is the scaled radius based on distance? Yeah,
and then you just draw it as a circle, like the square root thing.
Right. Yeah. So seems to me that could be like a cheap way to get a computationally cheap way to get some kind of 3D graphics.
Yeah, that's a cheap thing to sort of visualize something. Yeah. Of course, you can also just draw lines in 3D between them. Like, the lines are pretty easy.
Oh, yeah,
Form the endpoints as the end vertices, and then just draw the line. Of course, then if you if you add Z to it, you kind of get a bit of a funny.
Yeah, if you could do lines and spheres, that could be actually very good for data visualization.
Yeah,
Like
it's
for-
gonna
for-
look like some sort of like the fake computer screens that you have in movies. They love having like things that rotate in 3D for no reason.
Right.
Also, my ear is hurting because the headphone is sitting in a bizarre way because of all this nonsense that I've got going on here. And I can't move it because if I take it off, it's gonna hurt more. The headphones. That is the ear pad is pushing that. This even happens when I lay on that ear. It's if I lay on the wrong spot, it hurts, and if I actually lift my head up, it hurts even more. Bizarre.
Yeah, well, headphones hurt after a while.
Not usually, not if I have them on in a normal way, but I think they're too far back.
So I
at
was
this
hurting
point.
the very top of my head where that thing
I'm
rests.
sitting more here.
Anyway, okay, well this stuff is interesting. I don't know how
Chip,
far. Yeah.
Maybe it'd be a good time to just pause because you guys have gone into some technical details here and just see if anybody has any
Oh
specific
yeah, we can
questions,
discuss anything anybody wants.
about the
Doesn't have to
direction
be about-
you're
Yeah,
going.
discuss
and-
anybody we can. Sorry.
And then you can resume getting into the bits and bytes.
Yeah. See, John was asking about SD driver.
Yeah, and I assume anything that's on people's minds might be here in the chat. But if not, they could speak up.
Yeah.
What kind of editor do you want to use for the programming?
You talking to me about the on-chip?
Yeah, what
tool?
style do you want to go in?
I don't know, some kind of full screen editor that would have some sort of context awareness and nothing as elaborate as VS Code. I don't think that's necessary, but something
Maybe like a Vim, or what was the other one? E something?
Oh,
Emacs?
Emacs?
Yeah.
I don't know. I know of Vim, VI, and Emacs. Stephen's
Does he know how to
Stephen's
exit
an
it?
expert at that.
The first time you open VI, it's like how do I get out of here?
Yeah.
You're like trapped in a room and with no doors, and then
Yeah.
you have to know that :Q exclamation mark will make you will save you.
Let's say
Yeah,
some.
your Shift X is deadly though, but yes. Your Shift X encrypts the file on the way out.
So is it going to be tabs or spaces?
Oh, well, okay, even better, I would say. So, when the tab and space thing's a conundrum. It is better just to have spaces, but for storage, it's better to have tabs, right? So I was
Well,
thinking
for
that,
storage, it's better to just compress the file to begin with. Like,
well, yeah, you could so easily run length compress your tabs or rows of asterisks or equal signs or whatever.
not even run length compression. You can just do straight up. Oh, I think that actually got developed in between the last form, or did I just not bring it up because it was like, I don't know, last form was dreadful. I added actually compression to FlexSpin at some point. You can actually compress the entire program. Not very well. It's currently just using a basic LZ algorithm, but you can get a couple percent out of that, because one of the guys was complaining like if you create like a big array in memory, it's gonna put a lot of zeros in the program, right? Because it sort of reserves it like that, and then it takes forever to load the program. Not anymore, my friends. I've made a simple little thing that basically it compresses the program, then puts a little stub in front of it to decompress it. And
Nice.
now if you have a program that has like a big empty array in it, it's gonna just crunch it down. Of course, if you have something like with a lot of what is called if a lot of like strings in it that share the same word, you can of course crunch those down as well.
So Chip, you were saying about spaces versus tabs.
Right.
Hello? Can you guys hear me?
Yep.
He's riding the fence on that one.
Who, me?
Yeah.
No,
You're saying both.
Well, I mean, tabs are good for getting someplace quick, and they're nice to store rather than a bunch of spaces. But if you had control over everything, you just do spaces and then at least do a run length compression when you save the file. And so that you know, all that tabbing space combination just becomes 2 bytes in each.
I was just trying to start an argument.
Oh, all right. Well, hold on. Look for more things to call out. Nicholas, what were you going to say?
Yeah, thanks. So I just have a question. I'm new to the whole propeller stuff and I've just been evaluating different solutions. So I'm working on a project that will control either 256 servos, most likely, or 256 steppers. It's like kind of like an art project. And Stephen was helping me out. He showed me his library for that PCA board that essentially uses I2C to control up to 16 PWM channels. So my idea was to then maybe use the Prop2 to have like each cog control maybe 2 or 3 of those IC chips through I2C to hopefully get something pretty close to real time. It's not moving that fast, so it may be hard to discern it, even if it was on maybe one bus, would probably be okay. But anyways, from an application standpoint, I was curious on how would you go about it in terms of memory, because my thought process was to use a Raspberry Pi to actually send the animations to the prop, maybe via UART or something simple, and then it would actually synchronize the cogs and then, okay, play through the animation where essentially the animation is like a two-dimensional array where for each element you have, let's say, 2,000 frames, for that stepper motor or servo motor
Yeah.
position. So I'm not sure what's kind of the best way. I mean, I guess I could just stream the data, but then I guess if there's
So you ultimately have to create 256 pulse measured pulses to go to each servo, or to go to all the servos, right?
Exactly. Yeah, that's why like Steven was helping me out. He was saying like, yeah, you could just use one of these 16 channel servo controllers that use I2C. So you basically send it a command of, okay, what pulse width to generate on what channel.
Right.
Because yeah, there's only 64 smart pins. So I was going to use the smart pins to have their own I2C bus, I guess, do like bit banging, I guess. It seems to be, that's how you do it. But
Actually, yeah, the library that I have, what I'm envisioning in my mind is the library offers one instance of the PCA driver gives you access to 16 channels. 16 instances of this in an array gives you access to all 256. And so then you just tell each channel at the index you want, 16 index to 16, right?
right.
You just tell each channel what position you want. And so actually sending the commands through 2 tiers like that is very efficient. And
Yeah,
so
that would.
in terms of time. So that works really well. Go ahead, Chip.
He could even PWM it if he had like a string of, I remember these like serial to parallel converter chips, like a 74HC595, where you can have a whole bunch of these things strung together. And so you set up your data and you clock in a whole stream of data, like for a pixel array. And then you hit one latch line at the end and it updates them all in parallel. So if you're talking about servos, you have like maybe 100 hertz update rate, and maybe you need like maybe get by with 2 or 3 microseconds for a whole frame update. So that becomes like the step resolution, right? So if you're gonna need between, let's see, either 50, I forget what the duty percent is. Does anyone remember on a servo what the duty percentage is for like all the way?
50 hertz, I think is pretty common.
How much?
Like 50 hertz. Well, they say, was it like
Yes.
100 milliseconds to 2,500 milliseconds pulse width? It's like your like position range.
Okay, there we are. So the pulse width is a minimum what?
500 or micro, I think 500 microseconds.
Half a millisecond, Chip.
Right, yeah.
Okay, 500, yeah, okay, it's okay, a millisecond, and then it goes out to 2.5.
Roughly.
Okay, so basically you have like, let's say 1,500 milliseconds difference. Is that right? From one end to the other?
1.5 milliseconds.
Yeah, 1,500 micro.
Oh, 1500 microseconds, yeah. So then how many steps do you want within that range?
I'm not entirely sure yet. I guess whatever would be like 30 FPS, maybe. It may not even have to be that much, but
Oh, you could go as fast. It's just how many pins in the end. But if you were to like string out 32 of those chips together and clock data into all of them, so you basically have like a 256-bit serial to parallel shift register with a synchronous update, then 1500. So if 1500 microseconds is your range, and you wanted like, well, if you took like, if you had 2 microseconds, that'd give you 750 steps. That's like, would that be a little over 9 bits of resolution? That's probably plenty, right? I mean, maybe what you're doing, 6 or 7 bits of resolution would be all you need.
yeah, I haven't really done any calculations on that. It just has to really go between like 0 to 120 degrees of kind of positioning. In terms of the step, I mean, yeah, the angle maybe like 2 degrees. Kind of
Oh,
very.
Yeah, so that would only be, so 0 to 120 degrees is the range.
Right.
And you would need like 2 degrees. That would only be 60 steps. That's like 6 bits. That's easy. I mean, you could go, if you were to update that whole array at 6 microseconds, you'd have 8-bit resolution, which would be 4 times as good. And that would, 6 microseconds at 300 megahertz is 1800 clocks. You'd have plenty of time to shift that data out and then update it. And you would just do it all as, just like you do like a pixel array. They shift out the data, but you would be updating all 256 servo outputs simultaneously. So you'd run 256 counters, in software, and then send out the new bit states for every one of them every 6 microseconds, and you'd get 8-bit resolution on your servo.
I did that up for Disneyland on a big lighting project with a P1 and 595s. The upside about doing it that way versus using the I2C based servo controller, which is nice because that I2C thing that Stephen is helping him with is just a PWM chip. So you're telling the chip what to do on the PWM side, whereas what you're suggesting, Chip, is manually doing the PWM, which again, I've done that for Disneyland on a very big lighting project. The upside of it, again, is you only need one-way communication. And with the P2 and smart pins, you can blast that data out very, very fast.
I guess, yeah, I'm still having trouble visualizing how that works. I don't know if there's like an example kind of schematic, because it does sound very.
So these chips, you just have 3 lines to control them. You tie them all in series. You tie one guy's serial output to the next guy's serial input. You run the clock and the parallel update to all of them. And all you do is you put a data bit out, clock it, put the next bit data out, clock it. And then after you've done all 256, you hit the update line, and then it updates all of the outputs in parallel that you've shifted into this big shift register.
Oh,
So it's a 74595. Is that what you're talking about?
Yeah.
I'm with you. So you're creating an N-wide shift register.
Yeah, it's really simplistic.
Which controls all the servo lines.
Yeah.
Cool.
I mean, since we only have 64 and we're a long ways from 256 anyway, why not just you could do it over 3 pins and you'd have plenty of time. I mean, we're talking to this PS RAM on this P2 Edge module, and it seems to work really well. And we're clocking data, we're running at 320 megahertz and clocking it at half that at 160 megahertz. And it works fine. But you're gonna have longer, for all those chips, you'd probably want to mount them close together on a board, but you could probably easily clock that thing at like 50 megahertz or something. You might have to get HCT. I don't know what's fast these days, or the V versions, but
let's see.
But yeah, you just have three digital signals going in and 256 parallel pins coming out that would each go to a servo.
Yeah, that sounds pretty good. Okay.
And then the way you'd write the code is you'd have an array of your target values for all of your servos, and you would just run a counter and compare, and then each servo bit is the comparison. You do a software comparison against your counter to the state of the servo. So you either get a 0 or 1. Is it 0 or 1 right now? So you set those bits up and then just shift them all out.
So
If-
the old,
Oh, go ahead.
so I was interested in hearing what John, you said you had some experience with this. What was your sense of you said there were advantages of doing it with a wide shift register versus PWM. What do you see those advantages or disadvantages? I'm learning too.
Oh no, what I was saying is that the SPI data stream is going to be far faster than the I2C data stream. And so you can do this. In fact, I used similar code in both cases. There's when you drive down the road and you see those giant signs that have the big, arrows that are flashing. So I wrote P1 code for a company that makes those signs, and we needed 32 PWM outputs. And this was on a P1. So I used the same code that I had originally done for Disneyland, where we used 4 of those 595 shift registers, and then from those, in our case, we used n channel FETs to control the lighting element. But when I do a lot of servo stuff with movie props and things like that, there's a little chip that happens to be a FET driver called a TC4427 that provides a very stiff output. So that's what I did for the Disneyland project, where we took the 595s, the signal coming out, won't handle much of a load. So we ran that through a TC4427, got a really stiff output, and they ran bunches and bunches of lighting elements, all low voltage stuff. This was before the days of pixels. Once pixels showed up, then that's all we do.
Well, I guess just to ask, so if I was to use that shift register concept, would I even need really the capabilities of an 8-core processor to begin with? Or do you think the Propeller 2 would still kind of be overkill for that?
Yeah, you could do a lot more than just that with the P2. It might be overkill, but the P2 will signal very fast.
Yeah, that's the key.
Yeah, it'll get the data sorted out. Now, these chips, I'm looking on Mouser, a 74 HCT 595 at 1,000 pieces is like 16 cents each. And you would need 32 of those.
Okay. You said HCT, right?
HCT, yeah, well, that's my knowledge, because we've been using FPGAs for a while. So back when we built things out of discrete logic, there was the 74 LS we'd use, and then we got to the HC parts, which are CMOS, and I think the HCT, if I recall, are faster, but there's also some parts that have, I think, V in the middle, and they're like really fast.
Huh.
So, but you know what? If you couldn't clock them at 100 megahertz, then clock them at 25 megahertz and do 4 lanes, so you have like 4 bits of data output, and then a clock and a parallel update, or do 8 at a time. You could go, let's see, because you need 256 divided by 8 outputs is what, 32. You're gonna need 32 chips. So if you did like 8 lanes, they'd only need to be 4 bits deep each, or 4 chips deep each, to get the 256 outputs. There's a lot of ways to cut the pie that could, reduce.
Well, you're going to want to do the driver code in assembly anyway, and P2
Yeah.
assembly is far friendlier than P1 assembly. I
Oh,
keep
so-
finding out as I have to go back and rewrite P1 code these days.
Oh, yeah, that's cool. Okay.
Yeah, the
And for,
P2
like,
assembly is even a moron like me can write P2 assembly.
Yeah, that's awesome. And then from like one last question, just from like a product integration. So I wanted to have everything on a PCB ideally. Would you recommend, is it easy enough to just use the actual P2 chip and just put any peripheral caps and power stuff, or should I just get the edge board? I don't know.
The edge board is nice because it's really well engineered, and so it's very good with heat management. So it lets you run fast. It has super good bypassing and very good power supplies and a super accurate clock source. So it's like very safe to use the P2 Edge. If you make your own board, it is, you've got to have like 1.8 volt and 3.3 volt supplies, which isn't hard to do, but it is kind of tight to route them around the chip and get the bypass caps where you want. I mean, in the end, it's just a circuit board, but it's a little bit of a pain.
I see. Okay. Yeah, I'll probably just start with the edge. Yeah.
I was going to say Terry's here too, and didn't he have to make the similar decision for some of his boards? On did he use edge module or did he use chips? And I think he used edges, if am I correct? Aren't I?
I did too in a recent game piece for LaserTech.
You did as well. That's right, John.
Yeah.
At least for prototyping, you can't go wrong. I mean, later you could save money, but it is expensive to design a board,
Yeah, well, I mean, yeah, we're still prototyping, and then I guess for that edge socket connector, is that like a proprietary connector for that P2 chip, or is it a pretty common?
We picked it because it's dirt cheap. It's a PCIX connector, and those things are like 45 cents. That's why we used it. And that's also what the microbit uses. It's this thing right here, right?
Oh, right.
The connector this goes into is dirt cheap. That's why we did it, because most connectors that are something like this are $5 or $6 each. These things are like 45 cents.
And you can get both straight up or right edge.
Right.
That's really cool. Yeah, I'm trying to think of other, because I've done a lot of IoT stuff, and you can get away with a lot in just like STM32 and FreeRTOS. So I'm trying to figure out other really cool applications for the Prop 2. It definitely seems to be more niche, but
what I want to do.
We're all here because we have a lot of fun with it. Sorry.
Yeah, it seems really cool.
So it was designed, literally the design goal was to make it useful and fun, because a lot of stuff has become kind of intentionally unfun, especially like when you look at modern assembly languages, they're like unmemorizable because they have these like 4 or 5 consonants in a row, because the only they figured the only
That's what
guy
they sound like.
Yeah. The only guy that was ever supposed to look at that document was the guy that was going to adapt the C compiler to work with it.
That's not entirely true. If you want to actually make use of these funny instructions, you do have to put them into your program yourself, but they have a nice way out of that. You actually do it in C, but there's a special function that will just tell the compiler to insert that particular instruction. And those have much nicer names. Like I think they have like real words, and they're like convert AP8 to EP32 or something. Now it's something like _MM CVT _AP8 _AP32. There we go. That's a real one.
So but the P2 assembly language was designed to be like, it was intended that humans actually use it, so that it conforms to like how you might think, as opposed to just what a compiler barely needs.
Oh, yeah.
Yeah, exactly. It's very nice. Well, sometimes you can get the compiler to do funny things.
I just found on your store.
I think there's something very interesting about being able to set the condition bits individually. That sometimes lets you do very interesting things. And you can also get the compiler to do those very interesting things, but only very sometimes. Because of course, when you're writing C code, you don't have this in mind. I'm gonna put this thing into one flag. I'm gonna put this into the other flag, and I can do a funny thing with.
Oh, yeah.
You're not gonna get that, but you're gonna get some interesting tests and if sequences.
Yeah, that's awesome. So I found this right angle socket. So are you referring to another one on like Mauser DigiKey that's 45 cents?
We probably sell ours for what, a couple of bucks or something?
Yeah, it's like $2.29.
Yeah.
But that SKU number looks like that's your SKU numbers. They're like I don't know.
We buy them in volume for like half a buck or so. At least that was a couple years ago. I don't know what they are now. They're I don't know how to call that thing out. It's like a PCI PCI header, what do you call it? Socket. or PCI edge connector. Let me see if I look on Mouser.
Yeah, they have edge board connectors on DigiKey.
Okay, here are some.
Yeah,
These ones are expensive, I'm seeing. I don't know what ours is called, but it's not a keyed socket, so you can plug it in either way, but it's designed so that if you plug it in backwards, you're not going to hurt anything.
Oh, that's sweet. And does it require any like some like M.2 edge require like a little screw to kind of hold it down? Is that pretty much
I don't.
just fine?
You know, we do have 2 holes that you can use. I know actually there is another hole. I don't know that it's required to keep it in, but you'd probably want to secure it if it was going to be subject to vibration. Sometimes even thermal cycling can work things out of sockets, you know?
Oh, interesting. Huh.
So yeah, on the edge, if you look at like on this side right here, you probably can't see it, but that is the 5 to 12 volts or 5 to 16 volts in. So if you flip this thing around, those 2 pins on this side are no connects. So that if you do flip this thing around, it's of no ill consequence because the power pins become no connect then. So
smart. Yeah.
But we use this because the what is it called? The microbit. We thought we'd just ride on the same connectors as. Actually, we go all in a row here, right? Yeah, no, we just string all of our things in a row. So it's solid I/O pins across this face. And then back here, you have I/O pins intermingled with the local voltage regulators for the various sets of pins.
Very cool. Okay.
But we've been through several iterations on this, and what we have now, it's super stable. It works really well, and we have nice switching supplies. And we have like a 0.5 part per million clock source down there that's like it's usable for GPS even.
Oh wow. That's cool.
So just little things, and we have like lots of bypass. Every 8 pins have their own 3.3 volt regulators. So if you want to do like some analog stuff, you can just pick a set of 8 pins, and there won't be any noise injected from other stuff.
Yeah. That's awesome. Yeah, that project you guys were talking about, making like seems like a lightweight RPI alternative, like it could be really cool. I don't know if you guys have heard of like Terso DB. It's like this SQL-lite distributed database that's meant to run on like embedded devices to basically essentially give you like edge compute and like edge databases in your clients globally. And this could be a really cool application of that, because if you could do that, then you could like just have these guys scattered all around the world and just for like essentially for really cheap have like a database distribution. I'm trying to think of
I don't know, you shouldn't scatter databases all around the world. I think that's not very
These are
good.
just
I think that's polluting the environment.
Yeah. Yeah. Well, ideally this is low power enough to where it's actually better. Then you can have like replicas of data and
well, there are like I think there are
like
lots
the fish will eat your database, and the fish will die, and everything will be banned.
What's the name of the database again? I didn't catch the name of the database.
It's called Terso, Turso DB.
Thanks.
Yeah, it's really cool. I'm using it for a client project, and it's like super generous free tier. You get like 9 gigs of data for free, up to like 1 billion row reads a month for free. It's like insane. And it's just because they're able to run on such resource constrained hardware that it's like virtually free for.
I'm a big fan of SQLite. I use it everywhere.
Oh, it's awesome. Yeah.
That's really great. Well, go ahead, Nicholas.
No, I was just going to say, yeah, I mean, that was all my questions. If anyone else wants
I'm just going to leave this run.
Oh, Robert has his mic on.
Conference. I had a damn conference I wanted to get. That's why I didn't come down there and help you, is because.
Okay, there you go.
Thank you.
Why I want to put everything onto the chip, because I think there's a lot of stuff that goes on these days with things being marooned in time. So it's hard to sometimes revisit like an embedded project and then try to modify it because things have like become incompatible. This is what I remember happening all the time anyway. So I want something that you can actually store source code and everything on and come back 20 years later and make a modification to it or a backup without needing any kind of outside infrastructure.
Yeah, they're gonna find that in 1,000 years, and they're like, "Oh no, it isn't Y10K compatible or something." I'm just gonna open up the editor and just gonna fix it.
Yeah, yeah. It's like a way to avoid. It's like getting outside the. It's like the compute world's like Las Vegas. You know, it's bright lights and flashing noise and all this kind of stuff. And so it's kind of like this is like a little quiet reserve where you can do your work without, you know, feeling like you're building on sand.
Just a little peace and quiet.
Yeah, peace and quiet. You can come back later and it's still there without.
But if you want a co-pilot, you know where to go.
Yeah. Yep.
I don't think it'll ever compete with it, but it's nice to have something that's simple and works all the time.
Yeah, I mean, you know, for inexpensively, for little money, you can buy a Raspberry Pi that has all the, you know, it's Linux based. So it's good value that way, but it may not be very good at interfacing to the real world in ad hoc situations where you just need to like do something quickly. It might be worthless for that. But the P2 shines in that area. It can always talk signals, and it can interface to things on kind of a first principles basis without.
I think the problem with the sort of having all this sort of stuff on, like if you use Raspberry Pi, you install the default operating system usually, right? Like very few guys go out of the way of even like stripping down the operating system to what they need. It's always going to have like the full thing on there. And there's a lot of stuff that may or may not go wrong there, right? It shouldn't really, but you know, there's what they say, if you connect an old computer to the internet, it's gonna have like 1 million viruses on it. It's not actually true, but it kind of is true, right? Like if it has any sort of network connection, there's so much code in there that it could potentially hit with something, and also code that's everywhere, right? Just like a normal Linux install that someone might actually care about writing like an exploit for.
Right, they have figured out the exploits. I tend to
Whereas if you write your
never
own
connect
little
anything
network
publicly
stack,
for that reason. Right?
if you write your own little network stack, it might have like 1 billion bugs in it, but no one's going to know about those bugs, right?
Yeah, it's not a target because it's insignificant.
Exactly. That's how you.
But it doesn't have to stay
Live under the radar.
insignificant. Come on, let's sell some P2s.
Well, it'll always be probably somewhat obscure, you know.
I know.
But
I know. That's why I'm attracted.
But I also like, you know, what we can do on a P2 is make something you write some code and it actually does something. It'll do it the same way every time, you know, down to the clock edge. And so that repeatability is important. And modern stuff doesn't work that way. I mean, you can't.
Yeah, that's something that's kind of almost astonishing about the P2 does it mostly, but the P1 does it perfectly because it doesn't have the hub slices, the egg beater. You can just, even in spin, you can just time something. It's going to time the same every time, right? Like even if there's a lot of different stuff going on, it's going to have the same exact cycle timing if you measure it. Kind of, it's the sort of thing that you'd think would be normal, but actually isn't, because there's all this stuff going on where it's like
there's caching.
Oh, there's like caches and there's like a DMA going on in the background for something completely unrelated that's going to take away your memory bandwidth. And then you don't know where your time's gone.
Ada, weren't you saying, I read a forum post I think you made the other day, that even in 2024 you cannot write a video game for Windows that does not suffer all kinds of timing interruptions. Was it you that said that, or had I read that somewhere
I probably say something like that. It isn't just Windows, it's just PCs in general. The problem is that well, the number one problem is that you're running a multitasking operating system, right? And some task in the background might like do whatever deeply stupid thing it does. And it's doing that while you're already maybe running a bit late for your frame. And it's going to take a few milliseconds of your CPU time away. And then, oops, now your frame's late. You've got a stutter.
Yeah, there's just all these indeterminacies.
And then there's the other thing is there is now in a vaguely normally built video game specific system, they don't exist anymore, but pretend they exist. You just kind of synchronize to your vertical blanking, right? But on a PC, there's no, you don't have a vertical blanking interrupt. You don't even usually have a callback for that. And like, what does that even mean when you drag your window from a monitor that maybe runs at 140 hertz to one that runs at 60 hertz? Like, what does that even mean? So there's like this bizarre issue of actually getting the frame pacing correct.
Yeah, let me show. That reminds me of something. Yeah, this matter of being able to sync to the video frame, it's like something so simple, right? But it
on something like
exist.
even on like the P1, it's very simple. You can do perfectly smooth animations just like right out the gate because that's the default. Like smooth is the default. Anything else is when your complexity creeps in.
Yeah, so here's the little yeah, this is the HDMI RAM, the HDMI driver that talks to the PS RAM interface, right? But not directly. It talks to a memory interface to the PS RAM driver. But this is the thing that is generating the actual frame. So this right here, this code right here is all that's running during frame generation, except for these two routines that do blank, one with VSync, one without. So what I did is
my version of audio is like a million times more complicated.
Yeah, this is it on the P2. This is all it needs. It's all anything really needs, but here it really is just no more than that. So here we
just do that.
Are we on the last? No, wait, do we do that? No, here. Are we on the last line? Question. If we're not, go ahead and advance to the next line. But if we are, read in get the updated pointer for where we're going to look in the PS RAM for our video data, and write a 1 to what winds up being this structure right here. It writes it to this var, new flag, and then we have a routine here you can call called wait new screen. And what it does is it clears the flag and then waits for it to become non-zero.
Yeah, basically some variation of that is always what happens.
Yeah, but that's all, and you can do that.
Actually, with the funny emulators and some of the other stuff, it actually has to do a far more intricate thing, where it actually synchronizes to the individual scan lines.
Oh yeah. Yeah, this week what we do is we just
that like getting the screen right. That's like the basic. If you synchronize to the individual scan lines, that's like where the real hardcore timing stuff happens. Because a scan line in like SDTV land is somewhere around 20,000 cycles, which is still a lot, right? It's like 20,000 cycles. So we can do a lot in there, and that's what you have to render one scan line. And if you can do that, you can just throw all the frame buffers in the trash. You don't need them. Just need like 2 line buffers.
Oh yeah. Here where I'm bothering to do whole screens because it's kind of more amenable to that. But this little routine here just flips the screen, so it
yeah, that's exactly how you should do it. That's perfectly, and it will work every time.
Yeah, here I toggle. This is what toggles between 2 screen ranges, and then I wait for the new screen, and then I toggle. So next time it will. Well, no, my line draw is going to use this, and then I clear based on the new address of the screen. So I go down here. This clears the screen, and then I draw. So to do something like in this one, it showed. Oh, this is the one that was spinning that big, looks like a capsule. I do my drawing, and then I just say flip screen. So this shows the screen I just drew on these lines, and then it points me to the next one. So when I loop around here again, it just does the next one. Actually, it just, yeah, this is the only drawing stuff right here.
Yeah,
That
that's just
the
how it works,
capsule,
right?
this flips the screen, and then this loops it. And that's all it takes. But, you know, on bigger machines, you can't even do something like that very reliably. But here there's not, this isn't better. It's just so
I mean,
simple that
you
it's,
could, the API would look very similar if you did this in like SDL or something. Or like, I don't know, direct draw maybe? No, direct draw would kill you just looking at it. But it's like Medusa but worse. But it would look similar in terms of what the function is like, but sometimes you would just not hit the frame. Just something
oh, right,
like
no,
the universe
sometimes,
just prevents your frame from coming
oh,
out at
yeah.
the right time.
I mean, a couple frames might have gone by, but because we clear the flag and wait for it to get set again in the loop,
Yeah,
then
that's
at
normal.
least
That's,
it gets us to the timing boundary of the next screen.
yeah, that's the normal thing. That's what everyone does. But the thing is, you're gonna hit that screen every time if you're not taking too long. Whereas on the PC, you can have something that's very, very unintensive, but it just kind of like the universe just wills your frame into missing.
Yeah.
It's very bizarre. Especially if you're not trying to synchronize the screen itself, but you're trying to sort of synchronize some sort of internal time. That's hard because sort of getting this pipelining individual frames sort of to go to the screen, that mostly works. If you're trying to draw frames at particular intervals that are not necessarily the screen interval, which is always going to create some jitter, but often that's acceptable because otherwise it's just not going to work, right?
Right.
You have the issue that there's no way to say I want to show this frame at this time, because all of the wait functions that the operating system gives you are like, it may wait as long as you want. It may also wait like 10 milliseconds longer, which is too much longer. And you're gonna miss the pacing.
Yeah.
And then how it decides to map those up frames that you push onto the frames that go onto the screen, bizarre.
Ada, did you say you were working on audio over HDMI?
Yes, I have a thing that audio was working on. I haven't really put it into anything useful, but it can play music on the TV and show like a picture at the same time.
Through the HDMI signaling.
Yeah, okay, so it does that. So there's like a number of components to that. The first one is actually taking a packet and turning it into the bizarre formatting that it needs to send out.
The Turk4, yeah.
Yeah, Turk4 and also the like strange way that it's framed.
Yeah, it's like SPDIF within Turk4 and it interleaves across.
Yeah, it's that thing exactly. Bizarre, my friend.
It's really bizarre, yeah.
And the other thing is, if you have your normal sort of thing that's running on P2, it doesn't care about sample rate. That's assuming you have something that's written for the DAC, right?
Mm-hmm.
The DAC can be set to any sample rate. The HDMI cannot. So what you need to do is you need to actually resample it to like 48 kilohertz so that the HDMI can take it.
Yep. Do you have code that does this? I got all.
You can find it on the HDMI. You can find it on the forum somewhere. I can let me find it. I have forum powers. I can find it.
Yeah, that'd be great. The thing I got caught up in is generating the BCH.
Also, some guy asked about too soon to talk about the self-hosting of keyboard input USB. That's been a solved problem. I have personally solved it, my friend. I have personally solved it. Well, that's a bit too much, taking too much credit. Actually, the Italian guy, what was his name? He did most of the work, and like the other guy originally wrote the USB that didn't have hub support. But look, we can use this immaculately red and white. I just realized that the color scheme matches. We can use the immaculately red and white Raspberry Pi keyboard that for some reason matches the color scheme. We've got to go in here. Look, we are all in on the red and white now. oh, strange things happening these days.
That's it.
But anyways, you wanted to see the HDMI thing. I'm seeing it. I'm just waiting for it to load because I don't know. I have like a million tabs open and now Vivaldi is out for my blood or something.
You're generating the error correction code as well? The 8
Of course.
Okay. Yeah.
They describe it very well, they describe it with like a bizarre graph that doesn't mean anything. What the fuck
Yeah.
is a syndrome, my friend?
Yeah, I was looking at the diagram just now. I was like, what the heck?
Like,
Yeah.
what does it mean? It's just a CRC, my friend. It's just a CRC.
Right. Okay.
Like just say it's a CRC because that's what it is. It's a special kind of CRC that you can do error correction on the receiving end, but I don't care. It's a CRC.
Thank you
you have
very much.
You have to look. Of course, this is like the first page. I've posted a bunch of versions onto that, right?
Right.
Just like read the thread, like how you do that.
Yeah, of course. Thank
I
you very
love
much.
doing that. I just finding a nice forum thread and just reading all the replies. That's a very nice thing. It's like absorbing the knowledge into your brain.
I will dig into this. But just off the top of your head, do you know how often are you generating packets?
For the audio, I'm generating one every scan line. But there's also you also need another one which tells the TV the very exact sample rate that it's going to get, because they actually did something smart there, which is they realized that your audio may not be perfectly in sync with your video, so they have this relatively thought out system where you can sort of express the exact audio rate as a sort of rational as a rational factor of the video pixel rate, not the pixel rate, the TMDS rate, which in HDMI these are not the same because you can have deep color modes where you need 2 clocks for 1 pixel.
Okay, yeah.
But yeah, basically it's a timing packet, and that has to be sent a bunch of times. I send it once per frame. And you can also do things like the AV info. I don't even know what it's called, but the one that lets you tell TV that's what the supposed aspect ratio is. I'm using what mode you're using. Are you using RGB full range? Are you using RGB limited range? Are you using YAF? Are you using the other YAF? That's another one that you can send once per frame. That's actually the first one I started with because that one's sort of easier to see the effect of, right?
Yeah,
because for audio, you actually need a bunch of stuff to go right? You need the clock packet, you need the actual data packets, and you need you just need these two, and they have to be correct. Whereas with the info packets, it just needs that once per frame, and then it's like, it's gonna change into a different different colors and look weird. That's what you're gonna see in that thread is the first thing I do.
Yeah, you can hardwire the info frame, but you can't really hardwire the audio. I mean, unless you want to send zeros, but that's not helpful to debug.
The audio you have to do dynamically, but the info frame at the beginning I did dynamically. But then like the clock packet for the audio, if you know the timing, we can actually compute that outright. You could do it dynamically, and that's what you would do if you had something where you were reclocking the input at some point. So you actually the clock could go up and down, but what we're doing is we're generating one sample every how many cycles, so we can compute one clock packet and just send that over and over.
Yeah. Okay.
And that'll be fine.
This is excellent. I will dig into this, and I'll just ask you a question over Discord if that's okay.
On Discord? Oh yeah, certainly.
Okay.
Bring them in.
Thank you.
I was curious, Chip, what are you planning to do with the 3D graphics on this standalone system?
Well, I'm just kind of curious to see what we can achieve. I think it would be neat to have around just for like, just to have as kind of a resource to be able to show things like do data visualization in 3D.
I mean, you could do like the thing where like the self-hosted OS has icons, but they're like spinning 3D things. It's gonna be like Temple OS. It's gonna be the best thing ever.
You're funny.
Oh God, it may occur to me that someone does not know what Temple OS is.
No, I don't know what that is.
Oh, I know it
It's
is.
like this bizarre thing. So basically, there was a guy who was like mildly going insane, and he thought God said to him, "You should build the third temple," but it's like as a computer operating system, and he said it should have 640 by 480 graphics with 16 colors, and it should run in ring 0 only, everything fully privileged, because we are all equal before God or something. I don't know. Anyway, so he actually built that, and it's like a fully functioning operating system with its own like compilers and everything. Like you can actually just go into the code and edit any program. And one of the things that does is it can render 3D little spinning icons inside of any text, mind you. It's like actually kind of clever.
I mean, it's
like
pretty
the guy was
interesting.
totally, but like the guy
he
is
wasn't
totally
mildly
insane, right?
No, he was
Yeah,
completely insane.
Like what was the thing about the N-words that glow in the dark so you can run them over? Unbelievably. Like the CIA sensed them or something. Like,
so he did.
But there were some impressive things on there.
Yeah. Like
It's
the,
called-
I
like
wrote the whole thing in
thing is
assembly.
really good, but like the guy is like was like completely crazy. Very interesting sort of bit of little internet well-known thing.
So this was on PC hardware, right?
Yeah, I don't know if it actually ever ran on like real PCs or if it's just a virtual machine that it could go in.
No,
I think
people ran it on real PCs.
Yeah, I think that's
Oh,
a problem, because that's a problem with a lot of these PC operating system projects, is that they sort of run into a barrier where they can't run on the real hardware because it's not documented enough. But I guess if you're just using basic VGA modes into like beep speaker, then I guess that works, because that's from the 80s. The 80s were good. They were good time.
You probably run it on a Pentium.
Yeah, but the sort of the idea of the VGA 640 by 480 mode is from the 80s, and it still needs to be supported because someone's gonna run their bizarre boot selection screen with that mode, right? And that's not a hypothetical. That's what boot selection screens often use when they're graphical.
Mm-hmm.
They just go for the VGA sort of. No one knows what that mode is called. I think it's 06 or something. Everyone knows mode 13, which is the 320 by 200 256 color one. But no one knows what the other mode numbers are.
Interesting. This Temple OS stuff looks very interesting. Here's a video. Huh.
Yeah, it's kind of a sad story.
But it's kind of got a lot of the stuff that we want, right? It's got graphics. It's got
Mm-hmm.
it's got like an editor. It's got a self-hosted programming language. It's got a file system. It's got a bunch of stuff.
I was thinking if you add like a feature where it does data capturing and databasing of the data for like science projects, then you could use the 3D graphics to display the data.
Yeah.
It'd be nice if you can add that into the applications that don't have to code anything. For like maybe like middle schoolers and high schoolers doing science projects.
How interesting. I want to look more at this Temple OS stuff. This looks kind of fascinating. So why is it sad? Is this guy still around? Is he okay?
No, I
No,
think
he
like,
offed himself.
jumped in front of a train or something like that.
Oh no.
It progressively got worse until it was over.
I see.
I think there's still a few people sort of developing this thing, like as a fork of something. I think there's one that adds network support even. which was one of the things that Gordon says is forbidden and shouldn't happen, but the other guy just did it. What do you call that? What a heathen.
It's a sacrilegious application, I guess, huh?
Yeah, it's sacrilegious to add network stack to Temple OS.
He has some programs in there where it's like you can like talk to God and like randomly give you a verse from the Bible or something.
Huh. How interesting. And it was all 640 by 480, huh?
Yeah, I mean, if you
Yeah,
go 640 by 480 4-bit color, if you go 960 by 540 with 24-bit color, you know, that's like how many times better is that?
Right.
Not many, I guess, but
he even wrote a whole bunch of games for it in 3D.
Wow. Huh. Fascinating. Well, I'll look that up a little more.
Did you hear that they released the Lisa source code?
Oh, they did?
Mm-hmm.
Lisa, that was the $10,000 pre-Mac, post-Apple II pre-Mac thing.
I bet it's worth more now.
Well, yeah. There aren't that many of them, I think.
How much are they on eBay now, fully running?
I don't know. Don't you have a CGI machine? Is that you?
No, I have an HP, I think 9800 series.
Okay. Okay.
With the plotter.
Nice.
George, let's see. Is he still here? George Dell. He had asked, let's see, I need to get it done. Talk about it as oh no, that's what I said. Is it too ambitious to consider editor? Okay, so George, you're curious about what the editor would be like on the self-hosting system? It would just be some kind of full screen editor that would be pretty context aware of what you're doing. It would be for Spin and PASM, unless we can come up with like a better language. But it would just be, you know, totally integrated into the system.
Is it gonna have like color coding in there and everything?
Oh yeah, not only color coding, but like gradients. I've showed you guys the gradient text, right?
Was that when you're doing the HT text?
Yeah, it was. Let's see, I was doing it on 1080p.
Was the VGA to HDMI converter?
Yeah, it's actually a component to HDMI converter. But let me. Okay, I don't want to bore anybody, but let me see if I can pull it up on the monitor I have really quick.
I remember the gradient text. It looks really radical. Like if you showed it to people in the 90s, they'd think like that's the future of what everything is. We're gonna have these crazy gradients on it.
Yeah, well, okay, so here's the idea is that,
of course, the actual future always disappoints.
Let's see, I think I have this thing on file print here. Let me see.
Until we as a society improve and stop using everything just to make more money, we will not have gradient text and cool cyber worlds where you like go in and it's and like meet people or something. I don't know what the fuck is. You're not gonna have that.
No, we already have that. It's like the VR thing.
Yeah, I mean we have that, but it's like no one uses it. It's not cool. It's not the future. We're not gonna have anything good until we as a society figure out how to not use everything just to make money and money and money and more and more and more.
Well, then that'll never happen.
Yeah, that's what happens.
The trouble is it's kind of like, so you need more and more money just to survive. Oh wait,
they move up all that money and then they sell to you like a
okay
thing that like breaks again, and you have to buy it again, and you have to buy it again for more money. But if you don't buy another one, you're just locked out of everything, right? That's like with phones, it's like that, right? You always have to buy the new phone. Always buy the new phone. Always buy the new phone. And you know,
Yeah, I don't
initially
want
you
to.
could
I don't
just
want to
not
be
buy a phone,
not
right?
cool.
I mean, it's not even has to do with cool. You like, you know, need the phone to like do stuff, right? Like there's something. Oh, you can only get it as an iOS and an Android app, right? That's like the only way to do some things. They require it because they assume that everyone has one, right?
Well,
know,
you
in
have
the
to have more
beginning, you could
cameras
just
than everybody else.
in the yeah, the cameras like that's the vanity thing. But the other thing
I
is
need
just
at
like
least 6 on mine.
if you don't want to own a phone, you can't. It's very difficult.
Well, you can't.
You know,
Yeah,
initially you could just not own any sort of phone, then you sort of were expected to have a landline, right? The landlines, you know, this from like forever ago, those like big bakelite things, they're like indestructible and you don't carry them around, so they're not even, you know, you just buy it once and it will work forever until they turn the pots off because they want because they want to sell you more DSLs or whatever. But like, you know, now you have these like glass ceramic weird squares that cost like $1,000 and you drop them and they like immediately explode. And if you try to replace any part on them, they call the police. They arrest you. Roger that.
You got, let's see, if I pin my window, it's, gosh, it looks so much better on.
I think it doesn't pin it for me, but I think I'm in gallery mode. It goes to speaker, then I can see it.
Let me see if I can hold this neutral density filter, but you see there we have like italicizing that leans both directions. And we have gradient.
That's like cursed. Like a typographer would stab you for this. You don't italics backwards. But maybe that's the future.
This.
Well,
Hold on, I got this filter here that might help. Shoot, there's so much. Let's see if I can get around the shadow.
I think the problem is that your camera's like 720p.
My camera's at 720p.
That's not 720p. That's less than 720.
And that was a criticism.
Let's see. How do I?
My camera is 640 by 480. And if the frame rate is set to more than like 10, it has like horrible JPEG artifacts in it. Because it's this bizarre construction where the camera takes a picture. But because the USB 1 interface that it uses can't handle that much data, it actually compresses it into a JPEG, sends it over the USB interface, and the computer uncompresses it.
geez.
Bizarre.
Yeah,
But that's how most USB sort of image input actually works. They do this JPEG thing. Sometimes they can do a YAF subsamples thing, but that's actually semi-rare. It's mostly this JPEG stuff, which is like Rube Goldbergian.
This is so sad. I wish I could just get it to look right. It looks terrible.
Chip, when are you gonna get like an HDMI recorder?
The data path, the data path, the data path. Believe in the data path.
So you can just put it into Zoom.
I know. I have one, but it required like Windows 11 or something. Oh, actually, I have another little PC I could maybe run it on. I just don't have it up, but well.
Wait.
We'll get there.
Yeah, I'll just, I don't know. It's rare. Well, I try to share with you guys, but otherwise I just look at this. I wish you could see it. It looks so amazing. It's like, it's kind of like almost like a video game. We got things that can lean both directions, and we got gradients that run up the characters. You know, so you can. So my whole point is that.
Yeah, it looks like what the people in the 90s think is the future, as I said.
Yes, that's what it is.
It's like a Neo Geo, huh?
Neo Geos don't do that, but Neo Geo sounds cool. I mean, Neo Geo barely does text to begin with. It's like.
Well, the text they showed, they'd have gradients going up.
Oh yeah, they do have gradients.
But that was like a graphics. I don't think that was text.
Yeah, at least on like the Metal Slug, that the little score text has gradients. Actually, I'm gonna just turn it on because I have nothing better to do. while I'm listening here, right? Like of course I care about you guys.
Yeah, it's very.
But I need to turn on the bizarre monitor that keeps turning off when it doesn't, when it turns on again. I think I've unplugged it for this reason.
Yeah, I'm
Chip,
sorry.
this is being generated by P2.
Yes.
The what?
Yeah. I wish you could see what my eyes see. I mean, there are some gradients that look like flame almost, you know, and there are some that look kind of icy cool. It's just, but anyway, the point is that you've got types, right? When you write code, you have types. You have like system commands, you have keywords that of different types, you have variables of different types. Well, with this thing, we could reduce the amount of colors to something small and then use italics. We could use color schemes that would be very simple and memorable, because a lot of like colored stuff, what do you call it? Color, what do they call it? Color highlighting?
It's just color themes or whatever.
Yeah, they're like, all you can do is pick color. Well, here I've got like character.
You can actually do bold, I think.
Yeah, I could do
italics, but no one does that.
I have bold here too, but this camera is just not at all doing this justice. Let me see if I can, I wonder if by chance.
Is this a gradient or am I just blind? Is that a, wait, I have to.
Let's see, does this work any better?
Is a gradient?
No, this is bad too. Anyway, my point is that you can also use thickness and italicizing forward, you know, neutral, forward, and reverse.
Yeah.
And so what you can do is you can make more memorable subtypes that are easier for your brain to recognize than just tons of different colors, because you can kind of introduce a few other things into it that you don't always share everywhere else, right? So the idea is that for your brain, this would be like easier to kind of, it's like a visual mnemonic, you know, that makes it simpler for your brain to realize what it's looking at right away. Anyway, the editor would have, it would, you know, involve things like that.
So when are we going to have a very, very basic text editor on the P2?
Yeah, that's like the basics. That's the
super
sort of
basic
rope structure that you actually need to edit the text, because that's kind of tricky, is it not?
Well, we just have to have, we have the file system. I guess what I got to do, I got to get the USB thing done.
I mean, with the P2, with the sort of size of the source files you're likely gonna have, and with the sort of CPU power that there is, you could probably get away with the really stupid version where you just like press the button and then it sort of shifts over all the bytes that come afterwards.
Yeah.
They're like that incredibly inefficient way of doing it. It's probably fast enough, but like ideally you do it properly with like a rope.
Mm-hmm. Look, I want, my wife just walked in. You guys can meet her. Remember Michael? We went to Michael's house in Clear Lake, and this is Ada.
Hi.
Look, I'm looking
over
silly.
there. Ada's in Germany.
If you
So is this the person we complain to when Chip doesn't meet his deadlines?
Yeah, I guess so.
It's the big boss.
Yeah. The big boss, the controller. Actually, she's not very controlling. She and I get along really well.
They offered me the job.
Oh, they offered you? Oh, okay. She went to the county the other day to look into a job, so that's good.
Congratulations.
Okay.
So I have to let them know if I want it or not.
Oh, that's fine with me. How many hours a week?
I think it'll be a 40-hour week, or I can.
Oh, 40 hours.
Or they can schedule it less.
Okay. Yeah, well, that's fine with me. It's for the county, behavioral mental health. Is that
not mental health? It's just health services.
Health services. Yeah.
Well, it's good to help people. There are some out in Rocklin. Tim, I have one question for you. Since you are now working on a display driver on a P2, what I really would like to have from you would be a P2 I can connect and display the debug displays?
Yeah, well, that's kind of why one of the reasons I brought the anti-alias line draw over and want to do 24-bit graphics is because we can do all that stuff now. Now I've got to bring the other shape drawing thing in that draws like the kind of ovals and rounded edge boxes, because that's the other part of that. But yeah, with the line draw, we can start doing all those displays now. I also got to make a thing though that will put the fonts on the screen.
Yeah, because that would kind of solve a lot of problems when you can just plug it in between. You know, you have one serial in, one serial out to your programming environment. You just shoot it through, but you can display the debug on a second window on the P2, and you can do it way faster than over the.
Yeah.
I mean, if it's on the P2 itself, you don't have all those delays. You have basically with serial ports in Windows, or it's kind of probably faster and without buffer delays where you don't really know if it's done or not.
Right. Oh yeah, no, we could really like tighten it up on the P2 and make it super cool and responsive.
Yeah. Well, that is keep that in mind, please.
Yeah. And yes. And we'll also ultimately, we hope to have, you know, JavaScript compilers that can shoot out of the P2 to a browser if you want to work from the PC.
Let me throw a wrench in the works here. You're pushing hard to get HDMI and making other sacrifices, but then using up a bunch of pins to do it. Is that correct?
Well, 8 pins, yeah.
Yeah. So, and not every project is going to have a display on it all the time. I almost, had I been consulted in the beginning, would have, well, there's times when I want to use more pins than on projects. When I'd appreciate actually having those pins if we could do a different output, a composite output, and
yeah, composite PAL 5
and use a converter.
lines,
And you know, this one project where I want to do hook up my IDE and do all my work on it, great. But I need those extra 4 pins to actually interact with the world. And it doesn't actually live with the display on it. And,
well, what about this, Shannon? What if we could just as easily as we could target the chip you're working on, over 2 pins, we could target another module or, you know, another P2 system that may not care about a display, but could otherwise inherit everything else that's going on the platform you're working.
Yeah, basically you have to have your P2 development system and connect the propeller you want to program.
Yeah, you just say what pins you've connected to the other propeller chip, and it can just treat that thing as a target system and shoot all the code into it. You know, that becomes the destination for all the compilation.
The pin question is pretty much moot then, because it's the serial boot pins to shoot over the program and get debug info back, you know? I mean, you could...
How is that? Well, okay, no, I like the development on the P2, but how is that different than, say, hooking up your laptop down through the serial and program headers?
The difference is that you updates on Windows on your laptops will kill your laptop in a couple of years. But if you have something outside in a well and you run down with your P2, which might be also 20 years old by now, but it will still work. And will still program
no,
that
I
thing
appreciate
down
that,
as well.
but it's another device that
It
will
would be
certainly work if you have one.
Yeah, it would be a kind of a quite extended prop plug. Prop plug.
Yeah, I
would
mean, you
be
could just
about
use a
it.
PC as well. It's not like you have to use that thing, but you
Yeah.
can use it, and it's always a safe backup, right? Like,
Yeah,
I don't know. I have my 40-year-old computers laying around. They have passed into fantasy, and you know, you just plug them in, you turn them on, they just kind of work unless they're like physically broken, which is more likely something like a belt and disk drive that doesn't spin properly anymore or something.
Yeah.
Like that's more likely to fail than the actual chips in the computer. And you know, they've got ROMs in there. You just turn it on. It will forever just do that when you turn it on. It kind of, I mean, if you store something on a flash chip, it's eventually gonna be bad. That's kind of a problem. I think the sort of NOR SLC kind of things they're a lot more resilient. I think they have a lot higher endurance. With NAND flash, there's actually an issue, especially when it's like a multi-level one, is that when you try to read it after like 10, 20 years, it's gonna fail.
Yeah.
I think there's some guys who've had their like BU fail because they haven't turned it on in like 10 years, because why would you? And so they turn it on and like the operating system is corrupted. And of course, because they have this bizarre DRM scheme, it's nigh impossible to actually get the operating system back on there.
Oh wow.
The other utility in having something contained in the P2 or contained in the micro itself in a school environment. I know my kids have trouble. They sometimes spend half the class trying to get logged in, or my credentials.
Oh, yeah, these problems are just huge, and they're persistent, and it's just nightmare.
Yeah, there's all this fast bloat, and if it was something that was a dedicated P2, well, there just wouldn't be any credentialing problems or any of that nonsense. It's like you've got a display, you've got the CPU, you've got keyboard and power, and that's attractive, but
a keyboard and display on the device that you're actually working on. I'd love it.
I think
not need a separate one.
I think it would be fun in ways we don't even fully realize yet, because we're just so used to the paradigm that has been extant for so long that we're just kind of like, you know, we're used to like George Dell said he had to reboot because his microphone quit working. Now this stuff, all these kind of things just go on continually, and we just live with them. But it'd be fun to have a system that you could like just trust to always work. You know, and I think it'd be a joy to work on, because
I mean, not having everything on there, like not having that direct web browser, might even be like a boon, right?
Yeah.
Like, I think there's some authors that use like really old sort of word processor machines, because they're like portable and you can type on them, but they can't do anything else. You can't do like stupid shit on them and get distracted.
You can't get stuck looking at X or something.
This is going to fit and leave room for programs inside of an edge without the 32 meg?
So yeah, I mean, we could make that work too. 512K is still a lot to work with, but we'd have to go to like a way lower bit depth display, or maybe just a text display, you know?
I think something that I was thinking of with regard to that is you know, you don't need to have a giant bitmap display. You maybe only need, if you're drawing text, you don't need to draw like a line on top of it usually, right? Maybe like the little squiggles if there's like an error. But I think you can do that sort of dynamically as well. Well, you sort of render that dynamically. And then you could have maybe like a little screen regions that's divided, like, you know how the thing works with like the VS Code. It always divides it into like rectangles. They don't overlap like windows in a window manager, but they're like rectangles.
Yeah.
That have stuff in them. And maybe you could have one with graphics in them, one with text in them and stuff like that. and for the basic 512K only configuration, you'd maybe be limited to not having any of the graphics screens. And then of course you can also just you don't need to RAM edge. You can just have like a single RAM chip and sort of like hot wire it into your system. That only takes like 6 pins.
Right.
I
think these have like a non-quad mode, right? You could actually, if you
No, you could even do it over 3. No,
yeah,
you could
that's what I mean. If you were insane, you can do it on 3 pins.
Because you could tie the data in and data out together.
And well, back to the color. 16 color, I think, would be pretty rich enough interface for an IDE, and in fact, doing scope sort of interfaces on it. You've got multicolors for different channels. I think 16 is
colors
plenty.
for general UI, perfect.
Oh yeah, it's sufficient. You just can't blend, you can't alpha blend stuff, but that's not the end of the world at all.
Yeah.
Is there any benefit doing your debug between P2s?
Wait, Jacob, what's that?
Is there any benefit by doing debug between P2s as opposed to like Windows?
Yeah, well, I mean, here's the nice thing. When you run programs, you sometimes blow stuff up, right? And then you don't want to have to like, we don't have any memory protection or anything. So if you're using a target chip,
there is protection of the 16 kilobytes in the top.
yeah. Well, there's that. I mean, that could be used to, I guess, bounce back from a wipeout. But if you're targeting another chip and you crash it, no problem. Just download to it again. I don't know how it'll shape up because it's kind of an adventure. As we get along and we get there, we figure out how those things will work out because they'll present themselves in the process of development.
Look, Chip, you told me about your development for the C62 by using your Mac because you can kind of fuck up the C62 anytime you want to, and it's there back.
Oh yeah, you mean the Commodore 64? We're using an Apple II as a source machine because it was super stable. So yeah, all you do is run the assembler, and then we had a USR mnemonic. Everything was 3-letter mnemonics, and that would go to my own code, which would then they would send everything over to the Commodore 64. And when the Commodore 64 blows up, it's no problem. Just download again. It's like you never lose anything. It's kind of like a sandbox.
Yeah, same.
Yeah, I mean the other thing is that you can use the full memory, right? Like if you run your sort of assembler on the same machine, you kind of run into the problem where that takes up some memory that you could use for more program, right?
Right.
You could just cram more program in there.
But who knows? Like we could in that 16K, we could shuttle stuff off to like I don't know, maybe if we have the PS RAM or whatever, and then kind of
the PS RAM could be used for like overlays. That would be really cool. For some reason, no one has done that yet.
Yeah, an overlay.
That would make it very useful to just. I mean, there's a lot of things you could do. You could do sort of dynamic loading of code, or you could do like, okay, I'm gonna explicitly load this overlay into this address, or something in between that.
Right. Actually, that happened. GCC1 ported to P1.
Yeah, that one can do it, but it's like
did support overlays, which at that time
that has overlays, but it also has this sort of dynamic loading of code, which they call XMM. Yeah,
I mean that was a different approach. Some guy, I think iSeries, it was iSeries. He convinced with linker scripts GCC to.
Yeah, that's what you can. That's how you can create an overlay. The problem is with overlays. I think with the GCC overlays, the problem is that they're kind of a bit hackneyed. I think the basic way of doing it with the linker script will only allow you to load that overlay into a particular location. You can't like just say, okay, I have all these overlays and I'm going to load them into an arbitrary address, and the code internally is position independent, which would be the best thing, because then you can cache any sort of combination of overlays into your memory.
You could even maybe get out of the way like the debugger does, like do some kind of context switch where you run fully run the user program, and then on interrupt, you bring the OS back into the picture.
Yeah, you could do that. Yeah. But basically, in my opinion,
Well, the problem is
the
that you
goal
can't
is to
really
program it
restore a
in-
lot of the P2 state, right?
Mm-hmm.
Like there's something, if you set like the streamer state, there's no way to get it back.
Right. Well, maybe one cog will just be off limits. I mean, we would need some kind of supervisor to stay in the background.
Well, the OS could set itself back up, right? But the user program would have to do that also.
Yeah, that is the reason why I think it would be nice to have a P2 programmer with a megabyte RAM, whatever. And you can attach it via serial to your board you are working with. You can catch all the debug stuff, and you can still attach your FlexProp on the Windows. It just rooted this. I mean, it just pushes it into. I mean, FlexProp even supports that you can give that number. So the 000 will program the first chip, and 0001 or whatever will take the next chip in line. You have built that into your boot protocol. So basically, FlexProp even already now supports that. I haven't tried it out, but Eric told me. So basically, you can attach between your Windows PC and your to develop application that developing P2. You still can work on Windows. But if you don't have Windows, you still have a second attempt to reach your P2, because we have that small P2 development system which can open the source code, compile and run, but it needs to compile without using any web services, or it has to compile on the P2. So for that reason, you definitely will need an ECM32 thing. You will need the HyperRAM to kind of use them. I mean, to compile, you need temporary files, and you don't want to run them on
Yeah.
but, you know, I
Yeah.
mean, you should run them in RAM, you know, and I mean, your file system basically would also work with RAM. I don't know if you did it already, but basically your flash file system should basically work with the EC32 RAM also. Shouldn't be that a problem. I mean, you have to format it every time you start it up because it's empty. But basically, it should run there also. Same principle. Then you have a overlay. I mean, Eric already did that. You can use the RAM in the E32 with a RAM disk driver in his file system, which is absolutely cool. I tried it out. It works. So you just you can basically treat the RAM in the Edge 32 as a RAM disk, which would allow for compiling, having temporary files in there and whatever, without really thinking about, because you can do it on SD card also. So yeah, there are, and I think, I mean, having kind of an P2 in between to display the debug, then we are out of the problem that debug doesn't really run in Linux nicely, except you can use now Peanut in Wine or whatever. It would be nicer to have it on a P2 by itself, and in my opinion, probably even faster for scope displays and stuff like that.
Well, yeah, then you can, you don't burden the target chip. It just sends data back at super high speed and you display it.
Exactly.
And if it blows up, no problem. But we could make it work on its own too. If we could keep one cog as kind of in supervisor mode, and hopefully no other cog shuts it down.
Yeah.
I could see, yeah, having just this development environment on the PSRAM edges as a development environment to hook up to all your others that you can, yeah. I think that makes,
my opinion, what
makes
makes
sense.
the most sense, to have it running in a separate P2. kind of an extended prop plug where you can
Right.
and you put it in between your USB. You can work with Peanut and it just throws it through. But if not, you can have the displays directly there and can run debug directly there, and that you probably can do way faster, especially for kind of scope catching or stuff like that. I think the P2 can handle that way faster from the same serial debug the chip is sending out, but instead using it on Windows, using it on a P2 and displaying it there. So I just wanted to push you in the right direction, Chip.
Yeah, no, I like
Yeah.
that.
It's making sense to me. It's starting to feel like a good fit.
Yeah.
Because I tried, I started with P2 with kind of one of those PE boards. I know P1 where I put that together, and the next thing I hit was that Sphinx from Michael Park. He had
yeah.
one compiler running on the P1. I mean, we had there that problem Ada described, that the programs you could compile couldn't be as large as the P1 is because the compiler was running on the P1. So
Actually, couldn't that do it? I think that we used like a multi-stage thing where it like
he did
wrote
it
the intermediate parts to the files.
Yeah,
I'm not sure if what that means in terms of
but
program
still
size, but
you couldn't. It was pretty good. You because of that multi-stage approach. But you still couldn't compile anything bigger than 25K or something. Most of the stuff was inside of different cogs, but he had kind of a mailbox and system on the end of the RAM and some heap, I guess you call it. So you couldn't use all the RAM with your programs. So there was some size limit because it was running on the same processor and it couldn't kind of do it perfectly. But having a second one to program might be simple. I mean, programming another chip from one P2 is as simple as it gets. You just shoot it over serial.
Yeah, everything's there to make it happen. It's just kind of built in that way. And you can talk fast, you know. We can, instead of going 2 megabaud, we can go 20 megabaud.
Yeah.
So, Chip, I answered in the text in the chat here while you were in the midst of your graphic discussion, but really a better answer to what I was trying to make in the first place. And this, what we're talking about now, really fits in. But I don't know if you remember working with HP 16500 storage scopes in the 80s, 90s.
No, I didn't have access to anything fancy. I got my scope from something devices. My dad drove me down to Silicon Valley, and for like $400, I bought this 20 megahertz analog 2-channel scope, and that was like a huge development.
Well, this one I only recall from college. I didn't buy it, but that's what I'm going for.
I see what you're saying.
If you roll back, there's videos of them using these old machines now, and it's got a touch screen and a thumb wheel. Is the whole interface. It goes through a boot up. It's on 80s hardware. Well, updated in the 90s too, but it had a graphical display of the device and the network connection to it and the storage connection, and it had empty slots in the back where you could slide in extra feature cards that made by third parties that here's high speed analog something or other, or this type of controller, or output controllers and stuff, could get plugged in there, and on the display it would graphically show this is the device enumerated what's plugged into that slot, and you click on it, touch the screen. Actually, they had little laser beams cutting across the face of it that you'd interrupt with your finger so it could get the touch position,
Okay.
and it would pop up the buttons for, oh, here's the settings for the card you just clicked on. And if you swap cards around, well, the display changes and the menus change. And those cards, well, back the way they did it was probably a slower process. But
Was this Tektronix or was it like Infinium or Keysight or
HP?
Agilent? HP, yeah. You know, Steven probably worked on that. He just got off the call. He worked for 15 years at Agilent in their in building like logic analyzers that would handle like, I think 1,500 inputs for like, and anyway, yeah, he probably would. He just got off the call, but he probably would know what you're talking about.
So that sort of thing is what I'm trying to make for the bench here. And actually, later on, think National Instruments and LabVIEW. Now they had code that you put in there to control outputs as well, and the whole thing executed and ran experiments and run industrial controls and stuff, all based on feedback and inputs. So that's what I was shooting for. But I was going to start on my bench and see where it got. But the stuff you're building now, the self-hosted high-res 16-color display that can do high-speed scope sort of displays on it, it is just custom made for it. So I might, well, I'll try to contribute more in that direction. Yeah, so
cool. Yeah, I got to get that shape drawing going. That's what I'm missing, and then the thing to lay the fonts into the image. Then it'll all be kind of ready to be put to whatever use.
Well, think about it. If you get all that stuff done, right? Your editor, your programmer, most of the main title stuff, as a side project, having a log of devices, because then you can have a standardized devices for measuring the real world that you could sell, and have your already built-in drivers, like for a temperature sensor, moisture sensor, I don't know, any kind of sensor. Because when HP was doing it, they already had a whole bunch of real-world devices that measure things. Then they came out with their computer, and they realized, hey, we can log our information on a computer digitally.
And there's a protocol I've been working up, serial protocol with all the extra devices that get plugged in, but effectively reporting, here I am, I'm one of these, here's my ID, here are my settings, and that gets carried through and displayed on the user interface for adjustment. And those I had earlier, 5-10 years ago, I'd done something tiny or similar on MSP 430s, and I was using RJ45 connectors. They could handle, and I had a lot of them, but it's still just, well, sometimes I had a couple extra pins where I was sort of a presence pin, a request to shut down, and I have a problem back and forth, just binary. But I think I tend to abandon that now and just go all serial. So actually, USB, I don't know, or a mix. Um, Still running Cat 5 around is easier. Getting long cables of Cat 5 is easier than USB connectors. But in the end, it's power and serial connection.
Yeah, in my opinion,
Pretty simple protocol.
in my opinion, OSB is a shame. And I mean, if you want to use USB, use a kind of prop plug. But in my opinion, none board just should kind of have USB on board. It's bullshit. It's we don't need that at all. The serial on the P2 is faster than any USB. If you can run P2
Yeah.
P2, you can even use your RS443 or whatever it's called. Is it so you have longer lines, you know, but basically, in my opinion, Parallax did that for a long time, that they replaced all them boards which needed a prop plug through boards which had built-in USB. And in my opinion, that's a mistake. They shouldn't. They should kind of sell a prop plug and just have serial connections on the boards.
Or just a console connection?
Yeah, no, just serial pins. Just you can plug a prop plug in or not. I have, I don't know, 4, 5, 6 edges, and I can use one prop plug.
Yeah.
I don't need, and on the other side, I can take one of my old one of those 127. You know, it's a.
Yeah, but most new computers don't have a console connection. You have to get a USB to a console converter.
Yeah, you need one prop plug, but
Yeah.
you don't need a USB device on every board. You need maybe 2 prop plugs, one for programming, the second one for debug or whatever. I mean, but you don't need to have a USB on every fucking board, and you can't use it anymore as pins. They are blocked by the USB chip.
Right. You know, if we have all the tools on the chip, imagine this. You have a list of things to compile, and then you say download it over these 2 pins. Download this file over these 2 pins. So you do a compile, and it automatically updates like any number of other P2s you have connected.
Exactly. That's actually what I'm doing currently with my 121 of 127. It has USB, so I have one programming port. I have another one where I have a plug on, and then I have plugs on every 8 pin groups thingies. Actually, 2 of them. So I currently could program up to 20-ish, 20-ish P2s on one, and I can all reach them from one. I just switch my serial port over to, and it's fast enough. I haven't really. I have it running here, and I wanted to make a post over it, but I haven't gotten to it yet because I'm busy with getting unemployed.
Michael, is that a soda pop machine by you? Like a what is that thing behind you that says buy one?
And why is your camera all fuzzy?
I know.
So that's smoke.
No, that's a tobacco.
Okay, I got it.
It's a tobacco box. Yeah, I'm living in kind of very
dark.
To Ada, I'm not living in a basement. I'm above ground. But it's basically a basement too. It was a 2-car garage. So I rented out my house and I'm living in my own garage now. Yeah, life gets funny. You
It
know,
does
when
look
you,
like
when you
you're
start to retire, life gets funny.
right. It does though look like your camera has like dirt all over the lens.
It might be, yeah. It might be.
It looks like there's moisture on it.
Yeah,
Well,
it looks
might be.
actually worse than my 640 by 480 motion
Yeah.
JPEG.
Oh,
I think
your picture comes up very clear. Yeah, mine is. Yeah, but probably it's the same problem I have, that I'm not visible in mirrors.
I mean, it looks like a almost. Oh, do you have like 1% Bigfoot blood or something like that? That could be it.
This is his retired video.
Yeah, my camera is retiring also. Yeah, I'm not yet retired. I have to do 1 more year. February 25. I'm looking forward to it, sort of. Because then I can start playing with P2s again. All my projects are on hold. I have one of those. I built. I talked. Ada, I need your help for that.
Oh,
You
my
know
help is
that
needed.
persistent vision thing, that you kind of take 2 LED strips and rotate them, and then you have kind of a sphere, which isn't really a sphere because it's just 2 rotating.
What can you
right?
explain it again? I'm like
Like the LED spinning clock.
Oh yeah, that's
Yeah, so
position- the
that
vision
you are
thing.
using the spinning. So what I did is I built a globe. It's kind of 4 LED strips, actually are 8 LED strips. But basically when you rotate it, the surface will be a globe of those rotating LED strips. So on the polar ends, all them strips are very tight together, and on the equator area, all them strips are kind of the lines are kind of farther apart.
Oh, the usual map projection.
So what
issue,
I
yes, yes.
basically need is somebody to explain to me how I can use. It's that thing with Cartesian coordinates and polar coordinates or something. In maps, they call it Mercator projection. So your map is square, even if the
What was the
Earth is a
Mercator
ball.
again? I think
right?
it's
and
I think Mercator is the common one, right? Like the
it's what
the
they
equivalent
do
linear
to
one.
show you. And what I need is basically the opposite. I need image in normal, like a picture or whatever, or for example, just a picture of a world map. But now I
So
have
you want to have like a picture that's like a Mercator projected map, and you want to unproject it back onto the
exactly.
sphere.
I need to unproject it to display.
Well, actually, I think this would be very easy with the globe thing, because right, the density of pixels doesn't really change, right? It's the pixels are very tight together at the top, right?
On the top, they are absolutely tied together, and on the bottom, on
And-
the equator, they are basically.
But in the projected map, right, it's like at the top everything gets really stretched apart because it's
currently it does, right? I need to
because that's like, so basically that just maps directly one to one.
currently when I project an image, it looks kind of weird because it's spread out on the equator and pushed together on the top.
I mean, assuming you have like
I basically need to make a picture which looks like it's smaller in the
yeah,
center
but
and
the
wider
normal
on the
maps,
ends.
this sort of normal maps that you can find should already be like that, right?
You can get images like that, and they project nice. I have an image of a Mars, and basically project Mars nicely. But I would like to take. I mean, if I take an image of just a caro papier, also a square,
of something that isn't
lines and
supposed to be a
rows,
sphere, right?
it will project as an like on your globe. You know, the lines are farther together on top on end, and they're farther away in the.
So what you're taking is an
I
image
need
that
to-
just
to-
is a
to
random
kind of-
image like of a Pepsi can or something, right?
Yeah, I basically need to get a square image into one which is squeezed down in the center and farther away
Oh,
from the ends.
the radius of the sort of ring around the sphere
Yeah.
is that's the same as the width of a circle, basically, at a particular height. We know that, right?
At
We
the
remember the circle
equator,
thing.
yes.
And
Yeah.
that's something to do with the square root of something.
So I basically need to squeeze an image in the center together and leave
Yeah,
the top and
you
bottom.
need to squeeze it, right? That's that. You
that's
know how
how
to
feasibility.
resample it, right?
Yeah.
You know how to resample. So what you need to do then is you got to take I have to remember how that worked. Think you gotta take yeah, the square root of the square of radius minus the square of the distance up or down from the equator.
Yeah, yeah.
Well, you're just doing
something like that.
Computing adjacent as opposed to hypotenuse, right?
I'm not sure about that part. I'm actually not sure how to display anything on my globe.
Because I had this kind of thing. I asked that perplexity. I was taking an arc cosine of an x value, returning an angle, and then turning that in, and then making a sine of that. And it goes, well, that's just the square root of radius squared minus the other side squared. So
exactly, that's what Anna just said.
Yeah.
The square root of the radius minus the square root of the as far as you get nearer to the equator, sort of.
Yeah, because normally that equation is used to compute the long part of the hypotenuse, right?
Yeah.
But by doing the radius squared minus the other side squared, you have one of these, and now you're gonna, if you have the x, you can get the y, or if you have the y, you can get the x.
Okay, I get it theoretically. I have no clue how to code it, but I will. But that's basically my that's the reason why I haven't posted about that thing. It's nice. I built it out of walnut. It's a large lamp.
Good.
But currently I can just put lines on it. Currently I just can put lines. I cannot rotate it, and it shows me lines on it. And they are still walking because I don't have an I just have that encoder which came with the motor mount and wheel kit. Quadrature encoder. I have that connected to the P2 and running kind of a stepper motor to turn the whole thing. So it's still walking around on me, you know, it's not stable yet, but at least I can display something. But now to have really a picture, I mean, what I really would like to do is projecting a 3D image inside of that globe. So you can walk around through your 3D model.
Wait, does that even work? I don't think it works.
So you're saying you just want to render something in 3D, right?
Yeah, actually, no, I have two problems. I render something in 3D, I can do. I did the math, I did that a couple of times in my life. Having a 3D model displayed on a flat surface of your screen, not a problem. But I need to display that 3D model on the inside of a sphere.
Are you trying to create a hologram?
Yeah, it's a rotating light strip.
Oh, but the LEDs are on the inside.
They are on the outside.
Yeah, but then you can't see inside.
Yeah, you look at it from the outside. But basically you should be able to project the kind of just a cube inside of that rotating sphere.
I don't think that works if the LEDs are on the outside, because then you just get a sphere.
Yeah, every LED would have to be like, maybe have like 16 directional facets. So as it spun around, it could present the pixel from that view at that angle. You know, so you have a whole bunch of pixels that are spinning like this, right?
Exactly.
Circle, right? And they're in a globe shape like this.
Yeah.
Well, every pixel, so you could mount those on an arc, but I think every pixel would need to have some like subpixels which shot in different directions, so that depending on what angle you are looking at this whole thing with, you wind up getting a different picture.
Yeah, but you do that because you catch that light strip at this different point of while it is circling around the globe. So if you look from behind, you see it at the different time, so it shows a different part of the image.
Well, but the lights.
It looks pretty weird, but currently I can just put lines on it. So I need to transform some map into basically the opposite of the Mercator projection, and I need to do the opposite of it, to have it wider.
Well,
so
you'd be painting
I'm
a
not
2D
sure
picture.
you've got to demercatorize it, because I think you think of those LED strips affixed at the equator all the way around, and if they were stood up vertically, you would project you would think of the Mercator projection on them. But now you're physically actually bending the top and the bottom of those LED strips to the center, and the ones at the poles will light up and be the right color as though they were the flat Mercator projection. But you physically bent them around to the position where they would be on the globe. So they will effectively slow themselves down.
It would be probably the
to
better
shine
projection.
correctly at the poles.
It would be show the correct image because the Mercator projection is kind of splitting the outside, the top and bottom, making them wider as they already are. And if I take a picture of a normal map, it would kind of show me how the world really looks without changing the image.
I think
That's the thing. That's what I was saying earlier, right? Like if the pixels at the top are already closer together, then you kind of want the stretched out thing on the image, right? Incidentally, if you look around on the internet, you can actually find pictures that are from the inside of a sphere, but like projected like that. I have one.
Yeah.
I have one around here. Let's see if I can.
Yeah, but I haven't figured out now how to convert one into the other.
Look, that's what I've got one of these laying around because I was looking for like a cube map for some reason. Yeah, that's look. It gets very distorted at the bottom, right?
It's a frog eye display, sort of. Yeah.
This is kind of like a full sphere, right? That's sort of been projected onto a rectangle.
Yeah, and I need to do the opposite, sort of.
Oh, it wraps around too. So
yeah,
the
like
sides wrap around, right?
Exactly. Maybe I don't know. It may look weird now because it's because I've got this.
Oh yeah, can you
stretched across
scroll
screen.
it sideways?
Can't scroll. This is the entire picture.
But it doesn't let you like. You should be able to rotate it because.
No, because this is just the picture. I do have a program somewhere that would let me rotate it. Let's see.
Is this in Germany?
No, this is just a picture I found on the internet. I think it's Tokyo supposed to be. I don't know. I was just looking for like Creative Commons panoramic images. Because you can turn these into cube maps, and cube maps are funny.
It's kind of inside of a
Yeah, it's like the inside of a sphere, right? That's what we were talking about, the inside of a sphere. I don't know how that looks when you put it on the outside of the sphere.
Why don't you just drain your LED strip so it'll work?
Yeah, just straighten your LED strips, exactly. Just put like one of these hair straighteners, just use it on the LED
Yeah,
strips.
you don't need to curve it.
Yeah,
Solved.
I just built it because I kind of stumbled about those LED strips and I had kind of a metal frame. And
Anyways, here's a cross program if anyone wanted to see that. A tab where you can rotate the picture around.
Yeah, right. It's basically now the inside of a spare. Yeah.
I wonder what happens if you try to. Can you look at that from the outside? That's a good question. But I don't know. Does any of these buttons make that happen?
Yeah, probably not. No. But I think if you kind of display at the right time the right pixel on.
Oh, that's I think what that is. Maybe I don't know what this is.
No, that looks wrong also.
How weird.
Oh, that's now a frog eye displayed. I know that.
That is something.
That's something.
Hey, maybe in a few years we'll all be doing this kind of forum with some sort of like 3D immersive glasses.
Yeah, like those new Apple whatevers that I don't know.
I
They're
heard
selling.
that-
I'm not entirely sure what the point of these is, but
The point is so you don't watch YouTube.
Really?
Chip,
They don't-
we're not going to be doing this in those glasses in the future.
Yeah, I'm tapping out already because Ada mentioned it. You do need a cell phone nowadays for everything. For example, I can't get a Google email anymore because I don't have a cell phone number because I do not own a cell phone. I have Skype. I don't have a cell phone. Never needed one. Don't want one. Actually, I have one now here for my company because I'm programming application for cell phones, which I hate. But basically I don't have one, I don't use one. But I'm falling off the cliff. I mean, there are things like Ara said, there are things I can't do. And in Germany, I couldn't drive a bus anymore in Berlin.
Without a cell phone?
To get a bus ticket, for a bus ticket in Berlin, you need a cell phone.
well, that's bizarre.
No, I mean,
Down here in
if
Augsburg,
you-
we don't need that.
no,
They
no,
will sell you like
probably-
horrible
you
paper
prob-
tickets.
You probably can buy a bus ticket at the bus there for that one ticket, but your monthly, if you Monatskarte here, if you have an abo thing, that's on your cell phone, and if you don't have a cell phone, you can't get a monthly.
And of course, it's like something that only works on iOS and Android, right?
Yeah, probably, yeah.
My Nokia Windows phone. What about that?
No,
That I bought like forever ago.
no, you are not allowed to
Well, in
pay.
some cases, it's just like a QR code that they scan. You can probably like leave the phone at home and just copy that QR code and like print it out. But like,
No, you need a printer.
Well, then you need a printer, right? Yeah. I mean, printers are horrible things.
They're horrible.
This one is like this is like a less horrible one. This is the one that we have. I'm pointing to it off screen.
Yeah, but basically, if you don't need a printer, they oh, wow, they
This is slightly less horrible. It's just massive, and sometimes it refuses to print. It like crashes. You can see it sort of. There's a bunch of error messages on the screen. Then it sort of reboots itself when you try while you're trying to print. And sometimes like you try to print and like it doesn't remember which orientation it's supposed to be. So like your thing just gets cut off because it's trying to print something that's portrait, but you set it to landscape, and it's like I think that's a driver issue more so. But
have you ever seen a line printer in action?
A line printer? I have a needle printer somewhere.
No, as a line
Oh,
printer.
line printer,
like a
that's like old
dot matrix.
We are going back to mainframes, yeah.
Yeah, I've seen one.
You mean like
Line
the
printers,
proper mechanical typewriter-y ones,
yeah,
right?
it's
It has the whole row of dot matrix.
It's basically it runs for each letter a bicycle chain and prints one letter at a time, one line at a time, and immense speed. I mean, those things were running out, I don't know, telephone bills for the telecom or loud. I mean, loud.
Chip, what were you working on with the
Amazingly
USB?
fast.
What's that, Jacob?
What were you working on with USB?
Not USB.
So I've got a mouse and keyboard, so I can plug in a mouse and keyboard, and I have it. I have one set of a really nice wireless mouse and keyboard here that has one little wireless dongle, and I got that thing working.
Yeah,
But
I thought you said you were working on something with USB. You haven't finished it.
I just wanted to interface to like keyboard and mice so that I could have the P2 talk to those things.
But Ada said she already did it.
Yeah, I already have that thing going. But I think it only works on FlexSpin. Yeah, it only works on FlexSpin, so maybe Chip doesn't like it. He's like, I don't think he has FlexSpin installed.
Yeah, no, if I had FlexSpin, I would have tried your emulator already.
Oh yeah, we can walk you through.
You're gonna have to walk me through because I'm not sure what to do.
So you go to like, well, depends. Do you want like the full GUI thing, and do you just want the command line tool?
Give him a full schooling. He needs
Yeah, let's do the full squirt. So what you do is you go to like the GitHub, right? Where is it?
Yeah, no, you mentioned it. I just have to. It's gonna be like an adventure.
No, it's actually very easy. The main problem is that when you want to build something that uses like a command line script, like what I have, you have to put it on your path, which you can do dynamically just by setting like on Linux you do $path equals, now you do export $path equals $path. No. Export path equals $path : tilde slash flexprop / bin or something like that.
Pretty easy, yeah.
Yeah, it's easy when you know what you're doing.
Is this why Chips isn't using it?
Easy.
Yeah,
well, that's what if you want to do the command line thing.
I'm trying to go towards as simple as possible.
There you go.
Here's possible is simply install FlexSpin in Windows. Just install that thing, download it, install it. It will take
to
the path.
Yeah, here's the URL. Just download it. Like share your screen. Come on.
Now, do we have everything we want from USB drivers?
Well,
no.
I mean, I think it'd be nice to have like the mass storage class supported, so you can use thumb drives. I mean, I think
that would be nice.
Better than micro SD.
I mean, you could
easier
even
to move a thumb drive.
All sorts of things. Easier than micro SD, I wouldn't say that, but
it's slower, but it's more common and bigger.
I mean, it's more convenient logistically for people. I mean, these little micro SD cards are cool, but okay, you unplug one, and now you got to move it over to a PC where you got to put in a little carrier. You got to have a way to like for the.
I mean, mine can take them directly, but it's like you could take this and you could swallow it.
Yeah.
Yeah.
That's it. The SD card, I kind of like leave right in the
swallow it, and then you're like, well, dead. And because it's probably toxic, I think. Anyways, that is the SD card that has all the P2 stuff on it, mind you. Interestingly, it is a 16 gigabytes, so
don't lose it.
Could put a lot of stuff on there. In fact, it also has all the P1 stuff on there. And that includes like multiple video and audio files and all sorts of things, like uncompressed ones that I have for like testing around. This never gets full, despite being only 16 gigabytes. Like that's a lot of data if you don't do.
That's a lot of data.
Silly things.
For P2, it's a lot of data, yeah.
But like one of these other guys, I don't even know where all my stupid boards are, has like a 64 gigabyte card in it, which is even bigger. And I think they sell like 2 terabytes now, which I think is like the largest size that they can do before the addresses run out. So I don't think they're going to make bigger ones anytime soon, because then they're going to have that disaster again where the old devices can't read it. Where were we? Chip, you must share your screen. We must walk you through.
Okay, so now I logged in, and now I download the 15 megabyte file, right?
Yes, it's a zip file, right? You're on Windows right now, right?
Yes.
Okay,
right,
so that's
I'm doing
because
that.
if you're on Linux, you need to build it from source.
Yeah, no,
is-
don't get there.
Which is actually
No,
easier, I
It
think.
says virus scan failed. Why did
Just
virus?
Yeah,
it's not a virus. It's good.
it's good.
More
Ignore it.
information. How do I fix the download errors?
Oh no, does he have like does he have like weird adware on his PC that pops up weird things all the time?
So it said that, okay, so let me go back here. So I go to download it, right?
Yes,
and
it's
it's
the
gonna
6.8.0.zip, right?
Yep. So it's downloading and then it says failed. Virus scan failed.
Fuck.
Da musst du jetzt you have now to kind of go into details and said ignore that or
Yeah, that's what I want to do. But I don't know.
Do you have a separate virus scanner on your computer, or is that built in from Windows?
that's
I
probably Windows Defender.
Don't know what I have running on my machine.
Probably Windows Defender running there, yeah.
So then I go to more information. Oh, Brave didn't let it download.
Yeah, Brave is a very funny browser. the guy who made Brave, like the CEO, he's got a very interesting history. So that guy was like he was working at Mozilla and they wanted to make him like the CEO and they made him the CEO. But then someone figured out that he's like basically donated to some sort of deeply homophobic thing, like about making gay marriage illegal in California. And then they threw him out as CEO and then he started Brave. Very funny. Like he was like the CEO for 8 days or something like that.
Oh, that was an expensive donation.
Probably.
Yeah, that's more expensive than he probably expected it to be.
Exactly.
All right, so now it's download. Oh, it says again on now I use Chrome and it said failed. Virus scan failed.
I don't know. I'm not getting that on Vivaldi. Maybe Vivaldi is real.
Okay, here we go. Virus scan failed. See, this is like a bit of my experience is like this. It's like everything is a darn.
Well, that's the reason
this
why
never happens to me. I don't know why, but this sort of thing never happens to me. Like even when I was using Windows,
Windows will kill us. Yeah.
I don't get viruses. I don't even get false positives for viruses. I don't know. I'm not sure what I'm doing, but
You must be running some third-party software for virus scanning.
Maybe that's sort of hooked into.
What's scanning? Is it Brave scanning it, or is it something else?
That's probably Windows Defender. There is some way you can.
Yeah, it says it says it blames Windows.
Yeah, Windows Defender.
Information about the attachment manager in Microsoft Windows. So that means I have some. See, an attachment. That means parasite. This is what I thought the case was. There's a parasite in the computer.
Bullshit. There isn't.
Oh no!
It's Windows.
Quick, deploy the cyber nuke. We must stop him. We must stop him.
never heard of
deploy the cyber nuke.
parasites
Deploy the
before.
cyber nuke. Deploy the cyber nuke. Deploy the cyber nuke.
Yeah.
Oh god, it's like a reference that someone might not get. So there's this. I don't even know what TV show it's from, but it's like a very popular clip where they like do this like TV show hacking, but then they're like getting caught because they're tracing back the firewall or something. So they deploy the cyber nuke, and like the other guy's computer like explodes.
That's not a real thing.
I don't know. I saw it on TV. It must be real.
Man, it won't.
You rename the file like .txt or something, or get around, or is it too smart?
I think they're too smart, but that's like
It won't even
bizarre.
let me download it because it has the. Oh wait. Okay, yeah. Let me see if I can do that. Good idea.
Like what I've done in the past, I
Again, let us see. Maybe I have like fucking whatever vision. If I see a shitty user interface, I can tell you what the button is immediately.
Maybe Ada's trying to take over your computer.
No, that's like
Right.
that's like the real thing from Eric.
One
It's
thing I
supposed to
did
be
in
signed,
detail
actually.
is
I don't know why it would even.
I was trying to
would
see
even
the
have a
file,
problem.
and I zipped it and put a password on the zip, and then emailed that, and it took a little while to come through, but when my virus scanner got a hold of it, or the Gmail got a hold of it, it's like, this attachment is password protected. We can't check it for safety. Do you really want to download it? And it was like, yes, please. And it was one way to sort of get around
Oh, no.
Go into your security settings and turn them all off.
So I tried it. I said save link as. So I overrode the .zip and put .txt, and it still says failed.
What you want to do,
Scan
maybe
failed.
copy the download URL.
All right.
So right click, copy link. Then you go and into any folder and go shift right click or something, whatever you do. Just open up a CMD, right?
You mean like a file explorer?
You want to open up a CMD, like a shell, and you type
Oh.
curl or wget. Wget probably works better.
Hat Windows nicht.
So
No, they have it in Windows now. It's bizarre.
can I do it under a DOS prompt?
Yeah, you open a DOS prompt. This is how you download files in the year 2023.
But wget and curl doesn't work in Windows.
No, it does work. It does work now. Believe
So I
me.
go wget and then the URL?
Either that or curl. I don't remember which one Windows has, but one of them.
I'll try
wget.
wget
And then
is not
paste.
recognized.
Then try curl.
CURL. Curl is not recognized.
Ah man, it doesn't
doesn't
want to do
know
it.
either.
I think you gotta go to like the PowerShell. You know how to get to PowerShell.
Yeah, not CMD, the PowerShell.
Okay, so how do I get to the PowerShell?
You know, guys,
Okay,
you
we
all
need the PowerShell.
you all don't understand that you're still using Windows 95.
Oh, command prompt admin.
No.
No.
No, it's a Windows 95.
It's a shell. Just type in shell in the search and see what comes up.
Type in PowerShell.
Something like that, or shell, yeah.
Yes.
Oh, okay, now I got it. Okay, now I'll say curl. And then that.
No,
thing.
now you want to write capital I. I'm just gonna.
Okay, so in
I'm just
PowerShell,
gonna
capital I.
Invoke, the word invoke.
So capital INVOKE.
Genau, dash web request, with web and request also capitalized.
Type it all in the chat, and then you can paste it in there.
Yeah, probably.
Okay. So invoke dash. What comes after the dash?
He's typing it now.
So it's something like this, right? Note that it's a dash out file with the thing.
Sorry, Benny,
computers are getting more and more easy.
It's just getting more easy. Oh no, I did not
Sorry, Benny,
imagine this was this difficult.
we're gonna have to cancel our Valentine's Day dinner. We were trying to circumvent Windows.
You know, that's the reason we need that self-deploy development on a P2, you know, because it will get worse. So.
Well, yeah, I mean, this is already, okay, so I got invoke dash, then what do I do?
Then you put the URL.
Hold on.
Paste it in.
Wait, how do I paste it? If I do Control V.
You just right click on the window. It's easier.
That's what I'm doing. Oh wait, here we go. No. If I click on the window, right click, it doesn't do anything. Wait. Term invoke is not recognized as a name.
Invoke dash web request.
Look at the chat. He put it in there.
Oh,
look
okay.
at
There we
chat.
go.
Chat, is this real?
All right, hold on. It still won't let me right click and paste.
Oh no.
Yeah. Well, you might as well just type it out because there's so much.
Kip, can you turn?
Let me go grab
turn the full screen share on. I want to see what's going on. I need to see it.
Oh, okay, there. I just got it. All right, hold on. Hold on, we're back in business almost.
Oh.
Okay, so now I'm going to say invoke dash web request. And then in brackets, I'm going to have the URL.
You don't want the URL in brackets. You just want the URL. I just put the brackets here because
Okay,
you know,
so it's just web request and then space.
Yeah.
space, then the URL, and then dash out file, whatever, right?
Okay, hold on. Then dash.
You might not have rights to write to the C backslash. You might have
It will tell us that. And then we
I'll
can
just
try
say
again.
E:\\.
Oh yeah.
Okay, this
You
request.
have to give it a file name. You have to give it a file name, I think.
Could not create SSL-TLS secure channel.
Ah!
Ada, can you
Oh,
hold
no.
your 300 baud modem to the microphone and Chip can repeat it on the other end?
Don't you have some DOS experience?
No.
Or
Oh no,
maybe a QR code, like a really dense
Invoke web
It's-
request.
Where is Steven when we need him?
oh God, no, it's not
Steven
it's
could
not happening.
explain that for you to you. He did almost.
I don't even understand anymore. I was searching for was another thing, right? Because shouldn't it be possible to because if I try
Can you
to
just write
drag
the whole
it
thing
into
out for
the-
him so he can copy and paste it?
Yeah, I can.
Well, I've got a big thing here. I did. It's like, it just says invoke dash web request. The request was aborted. Could not create SSL TLS secure channel.
Yeah.
So the
I think
command
that's
works.
so the command works, but it's
You
just
probably put the wrong
wanna-
URL in there.
Wait, wait. Oh, no. Okay, you have to apparently put this command in. I don't know.
Oh dear.
Like this. That's what PowerShell does to you. That's why we tried the other one first, but it didn't like that.
I
Again,
can see why you don't use FlexProp now.
This is not even installing FlexProp. This is just downloading the fucking file, like downloading a fucking zip file.
Yeah, the zip won't. Everything I have says virus scan failed. I can't even save it as a text file.
You should be able to do that. Like, there should. Can you please enable the screen share? There's probably like a 1% opacity text that actually tells you how to bypass the virus scan.
Okay, hold on here. Here we go.
Okay,
Here's what I've experienced so far. So if I click on this thing here, I can say save link as.
Just click on it normally or something. It's fine.
Okay, and it's going to go like this, right?
I can't. Oh yeah, it takes a while to scroll over.
Okay, and I'm going to say save. And then meanwhile, you see this action down in the left corner.
What if you click on the
What's
little arrow?
Yeah, the uplink arrow. What does that say?
Click on the little arrow. You have to click on the little arrow.
Then
and then
resume.
Resume is grayed out, so you need more information, I guess.
Is there anything else below that?
Then we go to more information.
And that just gives you this fucking help file.
Useless.
Okay.
No.
Okay, we have to figure out Chrome bypass virus.
Hold on. Wait, there's something I can do here. No.
No, get out of that. It's a rabbit hole of useless stuff.
I'm doing it. I'm figuring out. Okay, yeah, I don't know.
I mean, how do other people download this thing?
I'm interested.
It just works normally. It just
try source code zip, like just try one of the other different files and see if you get the same block.
Yeah, try the source code zip or the tar.gz. It's probably
yeah, see if the other files work.
Okay, so tar.gz, this one here, the source code.
Well,
just try the zip. Try the zip one.
Okay, so I'll just Nope, virus scan. Look, it says virus scan failed on that too. So then if I go get this thing here.
If you right click on it, right?
Yeah.
If you right click on it, does anything happen on the
Malwarebytes browser guard? What's that?
What's that? Yeah, what's that?
Oh yeah.
Oh no.
It's not.
Unblock this item.
No, unblock it.
Can you make an incognito tab that won't have any extensions in it? Go to like.
Hold on.
You're gonna go incognito. You gotta
Let me
go
go-
like to the menu and then say new incognito thing.
Can you use a different browser?
Let
Yeah,
me
just-
see
just-
if I
just-
can like,
Just use
Yeah.
Vivaldi. It's just use Vivaldi. It's gonna make your life better.
hold on. I need to tell it now to let me, how do I tell it to like, Windows Explorer settings?
How about security?
Should I turn this thing off?
No, that's just the shell
No.
extension probably. But why would Malwarebytes think that it's a virus? It's not a virus. I vouch for it. I have seen the code. It will only make your brain
Click
hurt.
on the security tab
Okay, on the right side of the computer?
on the top, next to general and
So
your
you turn the
Malwarebytes.
computer over and then you take the hammer and
Oh,
hit it.
this one.
Yeah.
Okay, automatic quarantine.
Why is that on?
It's behind a
Premium
paywall.
only.
It's only for premium.
And for,
Hold on.
Is it doing that? Is that you can just I mean, if it's in Chrome, you can just go to the extensions and disable it, right? You go to the little puzzle icon in your Chrome bar.
Okay, that would be,
Oh, there's scan options. What about scan with archives? Right in the middle there.
No, that's like the little puzzle. Click on the puzzle. You must click on the puzzle.
Like the puzzles.
No, in the middle of the page. Never
And
mind.
then you can go on the ... next to that, and then you can probably turn it off.
Can you turn that off
Oh,
on the
you
dot?
Yeah, no, you have to click on the dots. You have to click on the dots, my friend.
Go back.
Oh,
Malware.
malware off. We don't want.
No try. No try.
okay,
No.
now we'll try it again. Okay, so here we go. We're gonna click this.
Yeah, but malware is not viruses, is it?
No, viruses are a malware. Maybe. I don't think it.
Not traditionally.
Pip, you now understand why we need the development system on the PC.
Yes, we now understand.
Oh,
I
that's
don't
When
know
I
how.
try- when
How
I
is your
try to
computer this
download-
messed
Wait,
up?
wait,
Sorry.
wait, look, it did it. Oh,
No.
no, it failed.
No, you have to turn off the virus.
No, it failed.
Go back to that dot thing.
I mean, this thing.
Yeah, on the dot next to the pin. No. Go back.
Here, I go back.
We'll click on the thing again. All right. Do not click on the malware browser guard. Next, on the right, there's 3 dots vertically. Click on that. Remove it.
It could also be in McAfee.
Or manage your extension. And we'll turn it off temporarily.
Yes, turn it off.
Turn it
turn it
off. There's on the top. It says on, change it to off.
Also go to the back arrow
All
and
right,
turn
we're
off
good.
the other one as well. There's another
That
one.
might fix it. Let's see.
Okay, let's see. I'll try it again. Here we go.
Just try it. Yeah.
Oh, is it doing it? Is it doing it?
Yeah, got her.
No.
No.
Oh.
Click on it.
Yeah, let's go to the
Well, click on it anyways. What does it do if you click on it?
McAfee.
Well, it's just gonna give me the more information thing.
Yeah, try
Let's see if we go back up here. What is this web advisor? Could this be?
That's also McAfee's also a virus scan. Turn that one off too.
Turn it off.
Manage it.
Oh.
Turn it
Yeah.
off. Okay,
Yeah.
here we go. All right, we're gonna try again.
This is peak comedy.
Oh, even faster. So who got it? Who thought it was
Computer
bad?
chip designer attempts to
We're scanning this.
download a zip file.
Click
I
on
don't
show
know.
all. I want to see what app is doing this to you.
What is show all?
On the bottom right.
Show
Oh,
all.
show
Yeah, show
all.
all. Show all. You must see. Okay,
Does your browser?
your browser is managed by your organization. What organization? My friend,
I don't know.
I don't know.
Go
Just
go to a library and bring a little USB drive.
if you
with
click on one of these, what happens?
Yeah, but somebody's got a Dropbox somewhere. You can take that and put it where you
Yeah, I'm just gonna put this on like my.
Only thing I think of is
Your
going to
browser
Windows
is
Defender
managed.
and turn it off.
Mega.
Your administrator can change your browser setup remotely.
Yeah, exactly.
What administrator? You have been hacked, my friend. You have been hacked.
No, he isn't.
Hey, Chip, is your computers managed by somebody?
Yeah, the
I
guy
don't
is
think
called-
it.
The guy is called even Morocco.
I mean, there was a time when there was a time when we had a guy at work who was our like IT guy, and he would have like some network drive access through some VPN, but I haven't had access to that thing in eons.
I bet he's got your machine configured that way with all those virus checkers and stuff.
Can you try
I mean,
using
you can-
Mozilla?
Yeah, try Mozilla, or yeah, Mozilla is probably even better than
Okay,
Vivaldi
what
in
I
this case because
have
it's completely different. Try
on my
Mozilla, yes, yes.
machine, I just have Brave and Chrome.
Just go to
download
the thing and
Mozilla.
type in Firefox. Type Firefox. Maybe it will work.
Okay. All right. Okay. So here we go. Let's go to Firefox.
He needs some kind of protection if 10 people are going to tell him just keep clicking.
Okay, here we go.
Wait, ESR.
Firefox is no longer supported on Windows 8.1. Oh, that's why it didn't have curl, because it's Windows 8.1.
Oh, so can I even use it then? I have.
Well, yeah, it gives you the ESR. Firefox is.
Oh, no.
Oh no! How do you download anything on your computer?
I don't know.
Oh no! Okay, now we really have to figure this out because this is dreadful. It doesn't even let you download Firefox. Do you have Internet Explorer?
Can you send
Have we stooped to that low? We're bringing up Internet Explorer.
Chip, in my
don't
opinion,
see
you
it.
should just call
If it's 8.1, it must have Internet Explorer.
It should be built in.
Let's see.
Ask Steven. He needs to integrate it into your Visual Studio Code.
Just type like iexplore.exe into the search bar. It will find it.
Okay. All right, hold on here. Oh, wait, Explorer. Now I got this thing on my other Internet Explorer. Okay, here we go.
Yes, yes. Whoa, not
wait.
What? No.
Okay, yeah. Just use Microsoft Edge.
Oh, just a minute.
No, you don't want Microsoft Edge. It's evil.
This is only
But
choice.
maybe-
Can't use Explorer.
Okay, maybe try downloading Firefox with Edge so you can download.
Edge to go get your GitHub thing.
Why can't we just do it with the Edge?
Yeah, just
because Edge probably has the same issues. Brave and Chrome.
Well, let's
have the
find out
problem
first.
Then.
Oh, it's
okay. Here we go.
No, we're gonna install every browser. We're gonna install them all.
We already did it. Doesn't make a difference. It's the OS.
I have 8.1. I'm running Windows 8.1 on my machine.
Yeah, that's why it gives you ESR.
Go to
because
download a different build. Click on that.
Yo, you do want the ESR because otherwise you can't use it.
Click on the Firefox Citizen Support release.
even if you can download it.
No, you do want ESR. It will not
All right,
work.
just download that then.
Wait,
Just download.
Where do I go?
Download now. There's a big
Yeah.
button.
Click on download.
Because we're interested to know if this is going to get blocked just from a download perspective, because you couldn't even download the file in Chrome.
Oh, I
Click on
just
it.
to remove the extension remove the malware byte extension from
Oh, that's the other
Microsoft
problem.
Edge.
When he opened
Did it-
Edge, it's like
Does
he-
it?
No,
does it
you were in
download it
Chrome.
for the file?
Okay, so I think I clicked this, but it hasn't done anything yet.
You don't see your whole screen, so I can't tell.
There's nothing happening at the bottom.
Can you show your whole
I think
desktop?
with Edge it's like at the top or something. It's like a
Let me try
download
this
icon
again.
at the
If I
top
hit this
supposed to be.
button here,
Oh yeah, it's it's doing it. It's
There we
doing
go.
it.
Oh, virus.
I think you could just go to GitHub with this probably. But you
oh,
can also
look,
just
it's doing
click on
it 3
Firefox.
times.
All right, when it's
All right.
now click on the actual file there.
Wait,
Click on the
virus
actual
scan
file, does-
failed.
You click on the file.
Okay, so it's something in your OS then.
All right, so you have to go into Windows Defender and turn it off.
You have to go to the core. It's like HAL 9000. You have to turn it off.
Okay, so
Exactly.
do I go to system settings?
Yeah, something like that, or controller.
Oh,
I don't know.
yeah,
I think you
the
just type Windows
the
Defender
control
or something
panel?
in there.
Just type in Windows Defender. That should bring it up.
Here's the control panel. Does it?
Yeah, it should be System and Security. Top
System
left.
and security.
Just click on System Security. It'll give you more options.
No.
Alright.
Is
it under firewall now,
No,
or
I
where did they
don't
put
think it
it?
is. Where did they put it? Oh, I think Windows Defender is not in system and security. I think it's a separate thing. It's not a control panel applet.
Yeah, okay. Type in Windows Defender in the search to see if it comes
This
out.
reminds me, the other day, I was working with Steven and we were in VS Code, and VS Code is pretty overloaded with all kinds of things that pop up. And it's like all these apps. It's like, why would you want to be in VS Code and like run apps? VS Code apps.
What? What now? The what now?
We were in VS Code and this thing called this apps thing kept popping up within the context of VS Code. It's like, what is this? We don't
I don't
want to
know. I
run
switched to
apps.
like the open source VS Code, fake VS Code, like some couple months ago. It still works. I think okay, can you go back to Chrome real quick? I think I figured it out. You have to go to
Okay, Chrome. Okay, hold on. Here's Chrome.
Okay, you go to the dot at the very top there, the dots. Then you go to settings. And then you go to security. So there should be a security on the side somewhere.
On the left?
Yes, privacy and security, there it is.
Oh, okay.
And then you go to security.
Wait. Oh, security, okay.
And then you turn off, then we go to no protection. And allegedly that turns off the bizarre thing, allegedly.
You can turn it right back on after you download it.
Okay,
Yeah, you
then
might want to turn it.
you. Okay, we're gonna turn it off.
And then you're gonna go back to GitHub or
Even
to
if you
Firefox
just
or to
at
anything.
the bottom, just go retry those.
There we go.
Yep.
Let's see. Is it going to?
Oh, it
No.
still blew up.
So you can turn that back.
What's the?
You need to find Defender and turn it off.
So I have no protection.
Turn it back on.
Yeah, go back
Standard.
Your problem is in the OS, not in the browser.
Yeah.
And it's probably even in some temporary quarantine folder somewhere if you could get it out of there, but
Ah. Okay, so Chrome.
the only other one is like, I don't suppose private browsing would help you.
The browser's not gonna make any difference. You need to find your virus scanner.
I mean, Brave, Chrome, and Edge, they're all the same. They give the exact same error message.
Yeah.
Because it's
because they're all the same.
It's happening beneath them, right?
No, they're all the same browser with the different UI on there.
As soon as they go to write the file to your incoming downloads folder or something, it's panic.
That may not even be it. They're really just the same browser. It's actually they're all the same browser except for the Firefox. The Firefox is different. The Firefox is pure and unrelated to Chrome. Even Vivaldi is Chrome. Oh, and the Internet Explorer that you can't that they don't want you to use anymore. That's also not Chrome.
If you're up in Edge and you right click those failed things, sometimes you can do like accept the risk and stuff. Is there any right click option?
Yeah, this is the right click. So I could say retry.
Well, it's gonna give you the same thing, but like if you can you go to the link or something where it,
Oh wait, oh, this is the Firefox.
well that's you're just
that's also
that's
not
that
doing
blew
it.
up. Oh yeah.
When you right click that, what does it say for you in that download? The Control J probably.
Wait a minute, you mean for FlexProp?
Well, I just wanted to know if we could find that quarantine folder.
Oh, yeah, I have no idea. I don't know. Let me see here. Let me, this was Edge. Here's Brave. I can't. Let's see. Where is? Here we are. Here we are back at this.
Okay, I think I have a very bizarre workaround apparently. Apparently there's a thing that is neither curl nor anything. that can download files just sort of incidentally. Do you still have the DOS prompt open somewhere? Right. I'm gonna.
Yeah, I have DOS prompt right here.
I'm gonna hot as
Wait,
is that in
that was
any
not-
sensible look?
hold
Is that
on.
in a sensible directory? Because we're gonna need a sensible directory there. We're
Okay,
gonna
hold
need
on. Here's my. I was working in this directory, so
I have to find the thing again. Okay, this is in a real directory. Be good. Then we have to. I'm currently just assembling the command for you, because it's bizarre, and now it's, oh no, my thing has scrolled in a slightly obnoxious way. Yeah, okay, that's good. Then we need this. Okay, try copying this exact command into the thing.
right into this DOS window.
Yes.
All right, let's see. Where's the chat?
Chat, is this real?
Here we go. Okay. Okay, so GitHub. Here we go. This thing, right?
Yes. Access is denied. Oh man.
I'm just a guest on my computer.
Oh no.
See, like it takes a lot of modalities to be able to do this. Like not only do you have to be able to design silicon and write the compilers and work in assembly, you also have to navigate zero trust and legacy.
Right. Well, I used to not have this problem because this problem wasn't, this thing didn't, it wasn't like this.
Well,
this just kind of
what has
crept up on
happened?
me.
We have like a real-time demonstration of computer broken.
Yeah, it's like, you know, at some point, this every day dealing with this kind of crap, it just wears me down a lot and makes me think we just got to make Noah's Ark and just get out of here.
Yeah, just anything but this. What is going on even? Oh.
At least you guys have some knowledge. I don't know. I've never seen it this reluctant to download a zip file. Usually it lets me circumvent. You know, I can just say download anyway. But
yeah, I don't know what it doesn't even want you to do.
Well,
like
I don't
funny,
understand
funny.
how it's saying that your Mozilla Firefox file has a virus on it.
Yeah, how does that even
oh,
happen?
right.
Mozilla
It's
Firefox
like
is not a virus.
categorically everything has a virus.
Right, that's what it's saying
Everything's a
basically.
virus.
Well, you know what? That's what a virus would do.
That's what a virus
Yeah.
would do. Wait.
No, a
If I
virus
take-
would do that.
If I take a little that's gonna be
You need to blow away your computer. Start over.
Let's just just get a new computer. If I send you an encrypted zip file, would that work?
I don't
No, because everything has a virus on it.
No execute. Well, if he only downloaded a zip file with an exe in it and an exe file. If he goes to like right-click an image, just go to any website, right-click an image, and attempt to save it. Does it
so
let
let's
you do
see.
that?
So here we are at an image.
There's no image here.
I right-click this.
Save link as, you can just do that. Just do anything.
Total spectrum. Okay, this is an HTML file. Okay,
It
so
does say Firefox HTML document.
virus scan failed.
It did say Firefox HTML document in the file type, which means you have Firefox installed already.
Well,
It seems like
brave though.
When was the last time you downloaded a file successfully without virus scan fail?
well, I don't know. It seems like the other day, maybe. I don't know. It hasn't been this difficult.
What? I still have no idea what's going on.
This is not a FlexProp problem.
This is not a.
No. You know, one time so our Peanut executable is like 800K. And at one point I found this really cool EEX compressor that made it 230K. I'm like, awesome. We'll start just distributing the file this way. Well, it created this like contagion of virus awareness or virus accusation. And we had to like go to all these places and kind of clear our name and then quit using the compressor for anybody to be able to load the thing again. Because it was setting off all the virus alarms. Because
Yeah, that's like
it would start unwrapping itself in memory. And they go, hey, that's not good.
They sound the alarm and then they tell their friends, hey, there's this file that I successfully blocked 8 times, you know, tell your friends, and then
right.
You don't stand a chance.
No.
And since Chip just did that, nobody else of us can ever download FlexProp again.
Oh no.
Yeah, because we got at least eight refusals.
I think Chip won, huh? Everybody better get on Peanut.
No.
Wait, it did say virus failed on the HTML file that he just tried to download.
Yeah.
Am I seeing that right?
You can't
Oh,
download
and
anything.
look. Oh yeah, that's a brave. But
the problem is it tried to download it doesn't let you download anything.
Right.
But again, can you check if that you don't have Firefox installed already? You may not have it on the
All
thing.
right, so let's see, if I go to run like this is how I got into PowerShell. I should be able to type Firefox if it exists. Oh.
Does it?
Here it is.
Oh, we have finally got a different browser. Now let's go somewhere. Let's go somewhere.
All right, let me get let me copy our URL. Ooh, wait a minute. Okay, here's Firefox, right?
Yes,
I'm gonna put the this thing in here. Okay, I gotta sign in again.
No, you don't have to sign it. It just lets you do it.
But when it sees a different browser, it doesn't know it's the same machine or anything.
You don't have to sign in. It just lets you download it without doing that.
Okay, let's just.
It doesn't require credentials.
Okay.
Yeah, just go back. You don't need to be signed in. It just lets you download that without it.
Okay, so
you
here we
need to be signed in if you want to download CI builds, but
don't get your hopes up.
Oh, completed. It is completed.
Is it still scanning?
Wow. Open file. Oh, okay.
Wow.
Open file now. All right.
Oh, it's like mission control, like Apollo 11 just landed on the moon.
Do I hit this?
Yeah. Yes, that opens up the GUI thing.
Extract all.
Oh, you have to extract all. Yes, of course.
All right.
And then you can, in the extracted, then you can click on FlexProp exe, and then something wonderful will happen.
Okay, so now I go back into here. There's nothing in there. Hold on. But there's something here though.
Yeah, that's the go up.
But those are all compressed.
It's all compressed. Go back up to downloads.
Wait, to downloads.
On the up
here.
to downloads. Okay, sort this by like date so you can actually see what you're trying to do.
Okay, hold on here. Let me make this thing a little smaller. Search by date.
So it should be at the top or at the bottom. It's now. Right, there's a zip file now it's at the bottom. You have to invert it again. Or go to the bottom. Go to the bottom. Just go to the bottom. There's a FlexProp zip.
Yeah, but that's
okay. Now we right click it and extract all.
Yeah, but he just did that. I thought.
Now he's looking at the compressed.
Oh, go use 7-zip. Use 7-zip. Or use WinRAR. You have WinRAR and 7-zip. Okay, just use any of them. Just use anything.
Okay, extract all. Okay, here we go. Extract all. Extract.
And now okay. Is it there now?
It's in downloads.
Take you there, yeah, and then go in there more.
Go in there. Is there files? No, there's no files. Why?
I don't know. Let me see.
You're seeing the same behavior that our NASA computers have. Is I can download zip files on my NASA laptop, but I can't extract it. When I extract it, it gives me an empty folder, just like you have right here, because our NASA laptops or administered by an administrator, which prevents us from doing certain things.
Can you try using 7-zip to extract it, or just open it up in 7-zip or something like that? Go back to the downloads folder. Go back to downloads.
Okay, hold on. Downloads.
Yeah, exactly. Right click and use try to use 7-zip to extract it. Extract to. Just do extract to.
Yeah, one more down. Yep. But I'm guessing
Now it should be in that folder that we just were just in.
Oh, wait a minute.
Or just move it to the desktop so we can see it easier.
Wow.
Okay, hold on. Where did it go?
It should be in that downloads folder, but it'll
Scroll
be
to the top. Find all
Move it to the
folders.
desktop real quick so we can actually see it better. Or maybe it's at the top. We don't know.
I mean,
Oh,
make
it
the
was
window a
called
little bit
Flex
bigger.
Prop, right?
Yeah, you can
If
just
it
press
extracted it, it should be
FL.
a folder.
You should just be able to type FL.
There it
There it
is.
is, right there.
So now is there something in there? Oh.
Okay, there.
Okay. This is like the Apollo 11 landing. Do click the exe file.
wow.
Okay.
Oh, it's actually going. Now we're
Now
spitting
we have
something.
to go get your stuff, Ada.
Can you drop
Okay.
it right into that?
The problem with the funny emulator is you can't actually do that. What you have to do is far more cursed. Actually, what you want to do with this is probably want to copy the FlexProp folder into your user directory. That makes it easier.
Okay, all right. So hold on. I'm going to go to here.
You're gonna go one up
Up to
exactly,
here. I'm going to copy this.
and then copy that into whatever you somewhere. You can also if you just copy it somewhere where you will remember where it is.
Right here.
Yeah, if it's here, it's gone.
There it is.
You must
Okay.
you want to copy the path to that. But just leave this open.
Okay.
Now what you need to do is
Now we need to go back.
to github.com /, let's go
Wait.
let's go
Go
near
where?
human. I'm just gonna copy it into chat. I know the URL from heart, because I know all my URLs from heart. Just go to this. It's in chat. Chat is real. This is real. So now what you have to go, this you don't do, this doesn't have like releases or anything. You just go to code download zip.
Right here.
Yes. So now you have this zip file, right? You have to unzip it, of course. Look, now it's a zip folder. It's in the compressed folder. You have to copy it somewhere.
Is this compressed?
Yes, this is in a compressed folder. As you can see at the top, the compressed folder. You have to copy it
Okay.
somewhere else.
Oh, okay. Well, can I just extract it?
I think somewhere. Just
Well,
you can also just copy it out of this. Just put it somewhere. Just put
Okay,
it
here.
somewhere.
So I'll say copy, and then I'll go to where I put the other thing.
Yeah, that's probably where it's gonna.
Okay, right here.
Paste.
Okay, NeoUm.
I was gonna say,
Oh yeah, you have to extract it with 7-zip. The Windows zip folders hate you. They hate you. Remember? Windows zip
okay, so
folders
let me-
evil.
Hold on. Let me get rid of this
Just
thing.
delete this.
we
Okay, you
gotta
want to go
go-
back to downloads. And then you go to the bottom again. You
Oh, there. Now it has a
right-click
zip
this,
file.
and then 7-zip extract to it. Now it's gonna be the folder at the top again. For some reason, it puts the folders somewhere else. No one knows why it does this. It's gonna be like the last folder before the files start. In theory.
or you can press like N on your keyboard and it might.
Oh yeah, you can press just the Neo or just use the search bar. The search bar takes forever.
There we
There you
go.
go. There's a folder.
Tap that.
There's stuff in there. Yes. Oh.
Hold on, I'm gonna back up to get the. I'm gonna copy all that.
Yeah, you can.
Yeah, just copy the folder. Copy it somewhere where you're gonna find it. And then we're gonna put it, or we're gonna put it somewhere.
There we
Now
go.
with
Now,
now
there.
what you want to do is there's this file called config.spin2. Now you ought to go in there in config.spin2.
Is it in stuff?
No, it's just config.spin2.
Oh,
There it is.
config. I thought you were saying conflict. Okay. Okay, what do I do?
Just open this up, you need to edit some stuff in there.
Okay. Okay.
Oh, it doesn't like that. Drag it into
Uh,
like a VS Code window.
I know why. Okay, here. Let me move this thing over there and we'll say
Sublime text. Sublime text is also indeed Sublime.
volume.
Anything that's a text editor. There we go.
There we go.
So what you need to do is I think if you're using a P2 Edge, it should already be correctly set up for that.
Okay.
So what you need to go is you need to scroll down to the part where it says video, where it says something about video modes. Now the top one is the one that's actually enabled. What you want to say is you want to copy the HDMI. You have HDMI hooked up, right?
Yeah.
So take the one that's commented out at the bottom that says something about HDMI and copy it up. Or just uncomment that one and
Okay, so uncomment by going
to the top and putting a
there.
thing, or just doing that. You have to comment the top one. The top one is still active. You have to remove the.
Oh, I see. Oh, I
Okay,
see how
now
you
you have
did
to
it.
say.
Okay, hold on. Okay, so what we're gonna do is we're gonna like do this, and then this.
Yeah, they're all commented
and
out.
for this one here, we're gonna go. Oh, I have it.
Wait, no, that's the top. That's the bottom of the YPVPR one. What you want to go is you want just delete all the ones that don't say HDMI on top of it. Just it's easier.
Okay, hold on.
I think this is sort of confusingly made. I think. Yeah, everything that's below that's about video modes. You can also no. You want VGA base pin. You do need that still. You do need the VGA base pin stuff. That's important.
Get rid of LCD 6.
Yes, you want to no, you still need the VGA base pin. And you don't want the weird one from the LCD section. Go Control Z. Undo. Abort. Exactly. Just delete the part where it starts saying LCD something.
Delete this here.
Yeah, delete all this part. Delete this part. Below LCD. You want the LCD to also be gone. You just delete all the things that say video mode.
Right here?
Yes.